Okay, let us pray. Hope everyone is hearing me. True. Our beloved Father in heaven, I call upon you at this moment to come and be with us, bless us, such that this lesson can be done successfully, and at the end, when we all receive something that is useful to our life for future, we shall stay glorifying your name forever and ever. I have prayed.
Thank you for the word of prayer. So, Edward Kalumba, if he wants to say something, but I think I will respond to him later. So, keep inviting your friends, let them log on. So, we are going to introduce partial fractions today. So, it's our introduction lesson. And those of you who are against our long lessons, let me tell you, you are not going to be favored. I'm handling partial fractions from the beginning to the end. So I want my 20 people. Yes, right now we are on 50. I know we shall reach 70. But I just want 20 people who are going to stay with me until the end. You people, the notes are just 9 pages. Even if we just say we are going to give each page 30 minutes, or even 20 minutes, that means in 3 hours we shall be done. So stay on, be patient. Let's handle partial fractions from the beginning, from A to Z, and let us get it done. Okay. Now, of course, you all know how we introduce our topics in math. At least we first talk about something about the heading before we literally go to the details. So as far as partial fractions are concerned, I'm going to first show you what the syllabus wants you to learn. You all know that we always do that. So let me begin with showing you how the syllabus wants you to cover this and how much it wants you to know. Okay, let me bring the book. So when you look at this, you all know it is topic 4. So it was a term 1 topic, but we never covered it last holiday because we had other topics like trigonometry, topic 5, that were so demanding. You get? So why I want us to complete this topic today, it's because we just have 2 learning outcomes. All we need is to express the sum of simple fractions as a single fraction. After that, we do the reverse. You understand? Yeah. So these two, each of them is a reverse of each other. So I'll put here the R to mean reverse. Those of you have ever driven cars, you know that. Okay. You can see we shall talk about the proper fractions, then we shall bring about improper fractions. And when you see the term improper fractions, you see somewhere we have the word quotient. So you see why I covered polynomials first. So whoever hasn't covered polynomials, lesson 2, even lesson 1, is going to find it hard to understand the second Roman of the second learning outcome. Then we are going to deal with linear factors, quadratic factors, and repeated factors, and other factors. Or what people literally call what? Denominators. So this is all. This is what the syllabus wants you to learn, and nothing else. So whatever I'm going to introduce, that's our sense of direction. Okay, now we can go. So just like the way you hear the topic partial fractions, generally we are going to look at fractions in parts. We are going to have fractions, of course. Yeah. And these fractions are going to be in parts. And of course, we are going to look at how these parts give you, and you're going to look at how these parts make up a single fraction. So let's begin by considering something here. If at all we have a half plus a quarter, and you know these things, LCM is 4, here we shall have 2 plus 1, then we come up with what? 3/4. And I think all of you know that. So this 3/4 is a single fraction. Is our single fraction. Now these two fractions in parts, these ones that are making up this single fraction, are the ones they call partial fractions. So I can say that a half and a quarter are partial fractions. You get it? A partial fractions of what? Of the single fraction 3/4. It's not a must that the partial fractions are supposed to be only 2. Yes, we can have something else. You can have 2/3. So that has been like our case 1, case 2. So 2/3 can add it to 3/4. add it to 1/8. People know these things of LCM. So according to me, the LCM is 24. And here I'll get 16 plus, here I'll get 18 plus 3. Then I'll have 19, that will be 37 over 24. You understand? Yeah. So the whole of this is what they call a single fraction. Now this, and that, those are now what they call partial fractions. They are fractions in parts that are making up a single fraction, 37 over 24. Hope my math is right. Yeah? So we conclude by saying 2 over 3, 3 over 4, and 1 over 8 partial fractions. Or partial fractions of 37 over 24. And we have agreed this one is what we call a what? A single fraction. So there is some information I want us to add. You have realized that the single fraction that has partial fractions may be proper or improper. There are things they expect to be obvious, like what proper and improper means. So if you look at this one is proper. Why is it proper? The numerator is less than the denominator. Those are what they call proper fractions. But this one of ours, the 37 over 24, I render it improper. And why do we call it so improper? Simply because the numerator is greater than the what? The denominator. So I just wanted you to look at partial fractions numerically before you can bring in unknowns, and how partial fractions may be owned, or how partial fractions may make up either a proper or improper single fraction. Single meaning it is just one. So that is the local introduction about partial fractions. Before we can even do anything else, at least learn that. Have that simple introduction. Now, first things first. Before I even take you to learning outcome 1. You see, learning outcome 1, before you form partial fractions, they want to see how partial fractions give you single what? Fractions. So we are now going to put these things in reality. Yeah. What do I mean by reality? Let's now introduce some unknowns. Now this is the reality that we are going to face in the topic. That has been a preamble. So let's look at the reality. What's the reality in the topic? By the way, you people, let me tell you, the moment I'm done with this topic, most of the work is going to be done. This holiday, we are not going to study a lot. Why? The work that you need to watch is already recorded on the drive. So all those people, let me use this opportunity, have been so busy, I didn't get time to talk to all of you. If you paid, make sure before the day ends, that is tomorrow, tomorrow is a Tuesday. So before Tuesday ends, make sure that you have access to the drive. You people, this holiday we are not going to study too much. We are only going to be having revision sessions mostly, but there are topics, yes, we haven't covered. But according to the way I'm covering things, because today I'm completing this topic, you like it or not, from here I will complete. So, I think we shall just be revising things, because most of the work Senior 5 work, the work is already there. That is the fact. The work is already there. Make sure before tomorrow ends, you have access to the drive. The work you're supposed to watch is already there. I want to give you access, you make your own timetable. Because if you look at even the timetable, it has those parts of reviewing the work on the drive. And every free time you see on the timetable, it's supposed to be used for that. Hope I've communicated. So the reality. So as far as reality is concerned, I may have something of the sort. I may say I may have 3 over x. Then I may be adding maybe 1 out of x minus 2. Yes, something like that. I may be doing that. What do I get? LCM. I don't know if people recall. That the LCM of unknowns. I don't know if people recall that the LCM of unknowns is equal to the product. Is equal to the product of what? Of the unknowns. Every time you're looking for the LCM of unknowns, it is simply the product of those unknowns you're dealing with. Never stress yourself. However, there are techniques that come in, and I'll teach you those techniques with time. Yeah. And we are going to learn them in this very topic. Yeah? So when I come here, I'll just multiply the 2. Yeah. So when I get this and divide it by this, I get this. You understand? When I get this and divide it by this, I get this. And the reverse is true. Which reverse? That when I get, because there are things you've been doing in algebra, that when I get this and I divide it by this, I'll get this. What have I said? That when I get this and divide it by this, I will get x. And hope that is right. I think you see why the LCM is the product, because it makes the next work very easy for us. So when I get this here, I'll have 3 times x minus 2 plus 1 times x. What do I come up with? Get 3x minus 6 plus x over x into x minus 2. What do I get? Get for x minus 6. If you want, you can factorize. If you want, you can leave it like that. I can decide to leave it like this. So that means that these two, just like we've been doing, those two are partial fractions. Of that. Now this one is a single what? Single fraction. Get it? This and this have given us that. So the other ones are partial fractions of the single fraction. So target 1 according to the syllabus, they want us to do what we have done. Part B, they want us to reverse. Now let the single fraction give you partial fractions. That's what we are going to be doing. Yeah. I know no one is going to remind me about the screenshot, but please kindly take the screenshot. Those who were with us yesterday, you saw what happened. So I beg, take that screenshot. Maybe we can see what we can do next. Yeah. You take the screenshot. Please, Patricia, you leave our screen. I don't know why some people are disorganized. You come here when you are in oestrus, then you start stressing us. Someone take the screenshot. Okay, those who are following us, so we can go to our notes and begin. Actually, who was that person writing on the screen? I didn't get time to quote their name. Who saw their name? Anyway, I'll get the student. Yes, Emmanuel.
Yeah, I saw the password was Patricia's iPhone.
Okay, thank you. So here they are saying in the notes that earlier on in algebra, we have been simplifying an expression such as this. You see? Now these are two different fractions, and those are they call partial fractions. And on simplifying them, we get something like this. So we have said that that is what they call a single fraction. And someone may say, is that improper? Oh, it's proper. So I want to tell you that this thing is proper. Someone may ask what is actually making it proper. It's proper simply because the 2 we have on top has x, which x is to power 0 over, we have something like x squared minus 1. You understand? So the x we are having in the numerator has a power 0. The x we have in the denominator has power 2. So that makes it what? Proper. But we are going to see some other sorts of fractions which are going to disturb us. In that on top you have something like x power 4 maybe plus 3, but down you have something like x power 2 minus 1. Now because of these powers, the x on top is to power 4, the x down is to power what? 2. Now this one becomes improper. As simple as that. Proper, improper. Because of the difference in powers. But if at all it is not in x, those are obvious. You just look at the size of the number. Okay. Then here they are making some statements that we've reached the stage when the reverse process is of value. And it is something I said. That the second learning outcome wants us now to reverse. It now wants us to make a single fraction as 2. or more partial fractions. But what we've been doing earlier in algebra since primary, we have been getting partial fractions, reducing them to a single one. Now in this topic, they majorly want us to reverse. After all, we always do the other one even when we don't want. Realize even the topics we have been doing before, we have always reduced partial fractions to single ones. Now here we come to reverse the process. Yes, Gloria.
Good evening, sir. Good evening to everyone. Yeah, so you say that if the number up doesn't have an unknown, that it's obvious. I don't understand what you meant by being obvious.
What I meant by obvious, maybe if you have 2 over 3, these are just numbers, so it is obvious that this is proper, and 7 over maybe 5, this is also obvious that it is improper. But when we only have numbers, that's what I meant. Hope you get it now. By obvious, I meant if we only have numbers. So someone may ask, so there is something funny. You see in numbers, if you have something like okay, very fast, I'll say that we consider the power of x in both the numerator and denominator, in both the numerator and denominator, to tell whether you understand. And this is it. When you have something like 2 over x, just that, you all know that this 2 is 2x power 0. The x is there, but it is power 0. And you know this x is to power 1. Now, following the fact that the power here is 0, the power here is 1. You may be having something like 3x over 4x squared. This x is to power 1. This one is to power 2. You understand? Every time the power of x in the numerator is greater than whatever we have in the denominator, this is what we mean by what? By a proper fraction. Versus, if at all you have the same things to begin with, if I even go to the same thing, let's say you're having now x over 4. I know very few people could tell that this thing is improper. Why? X is to power 1, the 4 down has the x, and it is to power 0. So you're having the 1, you're having the 0. So you see that? You can be having 5x power 2 over x plus 4. You understand? But you all know this one is power 2 and this x is 2 power 1. So because of all those powers, the power in the numerator on x is greater than that down. So you like it or not, this one is what? An improper fraction. But you all know we always have what they call whole numbers numerically. How do whole numbers come about? Maybe you have 3 over 3, 4 over 4, 5 over 5, 6 over 6, 2 over 2, and everything. So what if I do the same thing here in powers? Let me put it here in the middle. What if you're having maybe x power 3 plus 4 out of maybe 2x power 3 minus 3, something like that. So I want people to tell me in the chat.
For something like that.
We are going to use the wish of the majority. Let me see if we use the wish, the right math is respected. We are seeing x power 3, even here x power 3. We've been talking about the power being less or more. Now the powers are the same. Where do you think that one falls? Does it fall under improper fractions or it falls under proper fractions? Where does it fall? Proper, improper? Where does it fall? Proper, improper? You see, people are very confused. Are saying neither proper, neither improper. You see, people are just I don't know how we are going to recall this because it will give people hard time. Let me see, let me see, let me see. Same power. Let me see how can we recall this, because remember this one is supposed to be improper. Someone may be like, why improper? Because when we do long division, something can be done. You all know something can be done by long division. Abdul, remove the green line you've put in our screen. So you all know that when we do some long division, something can be done at least. At least we shall begin with the 1, yeah? When you have x this here and x something here, at least long division can give us a 1 first. And remember, a 1 has no problem. The 1 being a quotient has never been refused. Okay, no one has ever refused it. That 1 should never be a quotient, never. If 1 can be a remainder, then why can't it be a quotient? So take that as an improper fraction because something can be done when we long divide. And we shall later see as we are studying this, that the moment they give you a single fraction and they want you to split it into 2 partial fractions, and it is improper, we shall long divide. That's why I'm basing on the reason or the fact that something in long division can be done for me to say that it is actually improper. But just like you people cram that mass is supposed to be in kilograms, weight in newtons, force in newtons, you cram or you learn by heart that when the powers of x are the same, improper. Powers of the x, if they are the same, improper. Powers of x when they are the same, improper. Powers of x when they are the same, improper. Powers of x if they are the same, improper. You can even be like, I didn't know about this. You can even be like, proper, I thought the power on top is supposed to be less. Then for improper, the power on top should be greater. But then if you give me a fraction where the power is the same, that is not proper. Hence an improper fraction. You get that? Yes. Understand it like that. Story format. I thought for proper ones, the power of x on top is less. For improper, the power of x at top is greater. But now you're bringing something where the powers are the same, so that is not proper. Hence an improper fraction. Why it's not proper? Because it's not among the rules you've been knowing. So the mere fact it's not right, the mere fact it's not proper, you take it as an improper fraction. Okay, so what are the targets? What are the lesson targets? We have agreed that the lesson targets are only 2. So the lesson targets, I'm going to have partial fractions here. And you all know partial fractions are the ones that make up a single what? A single fraction. And you people know that a single fraction is either proper, as we've discussed, or it is what? Improper, still, as we have discussed. So our lesson target 1 is that making sure that the partial fractions give us what? A single fraction. Then lesson target 2 is that making sure that a single fraction which is proper gives us the partial fractions, and a single fraction which is improper also tries to give us partial what? Fractions. And when we handle that, we shall be done. Okay. Our notes is coming to guide us. What are they saying here in purple? This is where I am. This is where we had stopped. Given a fraction such as this, it is proper, whose denominator factorizes, we may split it up into its component fractions, writing it as this, as we are going to see. So it is now said to be in partial fractions. This is what we discussed, that when you subtract these two, you come up with this. So this is the single fraction, and in this case it is proper. These are what they call the partial fractions, the one that give you the single one. Now the math has started. Example 1. They are saying express these two as a single fraction. And if you people can see, I think the signs they are using here, equivalent sign. But trust me, when you forget them, your work will be marked. But when you use them poorly, you may be crossed. I don't know if people are getting me. These ones, when you put them where they are supposed to be, well and good. When you put them where they are not supposed to be, that is very wrong. When you forget to put them where they are supposed to be, that is okay. Do you get it? When you put them where they are supposed to be, well and good. When you put them where they are not supposed to be, very wrong. When you forget to put them where they are supposed to be, it is okay. So I don't want that to stress you. I don't want that to stress you at all. Okay. I'm only going to do that, and we are going to do it together, and then we shall see other things later. So it is 4 and 2. It is 4 and 2. So we're handling target 1. That's what we have, and they want a single fraction. We agreed LCM of unknowns is the product, so I'll have x plus 6. I have x plus what? 7. And you all know, when you divide this by this, you get this. Isn't it? After all, the LCM was a product. And then what else? When I divide this by this, I get this. After all, the LCM was a what? Was a product. Okay. So when I divide, here I'll have my 4 into x plus 7. Isn't it? This by this, I get this. Now this 4 attacks it, and we come up with that. Understand? Then minus 2 What's up with the 2? I get this, I divide by this, I get this. Then the 2 attacks it. So we have x plus 6. The work is disorganized, you just need to follow the arrows as I'm putting them. So we have something like that. So I'll come and open these brackets. People have been putting their equivalent signs, which are very okay. If you can recall, if you can't, leave them alone. 4x plus 28 minus 2x minus 12. That's why even those who covered partial fractions from school, you might not have seen them anywhere. Yeah. So you can decide to, after all, you're not going to reuse the denominator again. You can also decide to open brackets. Yes, and be like, this one, I taught you this in polynomials. And I'm not giving an explanation. So I'll come. For x minus 2x, I'll get 2x. 28 minus 12, I'll get 16. This one will be x squared, plus 7x plus 6x plus 42. You understand? Yeah. Then I will conclude and say, these partial fractions you gave me for this minus 2 over x plus 7, what do you get? X squared plus 13x plus 42. You end there. But there are those mathematicians who always say, I always want to factorize my work. They can write that as 2 into x plus 8. That one is also right. So people, is that thing okay? I just think it's okay. I don't see any problem with that. If I'm okay with that, what if I use equal signs? Hey, thanks for replying that in the video. So you people, is that okay? Don't say yes, you say it is obvious. I want to see someone saying it is obvious at least. Okay, let's go back to our notes, but I'm going to complete this topic very fast. You see here, someone even here left their denominator as it was, which is very okay. It's still a product. For them, they never even factorized. And that is the beauty of pure math. Now you see this one? They want these ones as what? Okay, now for this one, it is a bit serious, and I'm going to show you how. This one is a bit serious. You cannot just panic about that, and we shall need the same concentration when we reach the main part. So I don't want you people to be tired, yet we are just handling target 1. So this one is a bit serious. We are giving it to x, and down we have that. We have 3 over x plus 1. Those are the ones we have. And they want us to make that a single fraction. But do you know what shocks? The people who are good at quoting our statements. Someone will be like, Dr. Utaya said that when you have those two, since they are unknowns and they are denominators, to get the LCM, you just multiply. And someone is like, here we have x squared plus 3x plus 2 x plus 1. Then someone says that is the LCM. And I want to assure you that is very wrong. That is very wrong. So here you're supposed to always concentrate. Never panic. Never panic. Never panic. So I'm going to put here for you a note for starters that you are going to use for the rest of your life, even when you reach campus, especially the engineers. So I'm going to say, every time you encounter a quadratic denominator, you see why I began with polynomials, because now you people know what quadratic is. You people at least know that quadratic, that is the format. You understand? So every time you encounter a quadratic denominator, first check if it is factorizable. Please first check that it is what? Factorizable. So yeah, I will say if yes, proceed to factorize it. You get the point? Check if it's factorizable, and you find out that yeah, it is factorizable, proceed and factorize it. But what if it's not? If not, treat it as it is. As it is. You people, they are quadratic things that are not factorizable. Someone may be like, how do they look like? Now you look at something like this, x squared plus 5. Because of the squared, or because of the degree to it is quadratic, but you cannot factorize it any further. It cannot go beyond that. Like that is its most simplified form. So don't expect it to go beyond that. You can have something like 6 minus x squared. Like for sure, what do you expect that to become? You cannot factorize and it is quadratic. Someone may be like, hey, but you said quadratic has bx somewhere. Yes, it has bx, but the b was a 0. So it disappeared. But if you really want to see it also, yes, that one can also happen. Like this thing, plus x plus 1. Are you seeing this thing? It is not factorizable, even when it is in the format of quadratic. It is in the form x squared plus bx plus c, but it is not factorizable. So the moment you realize it is not, please treat it as you're supposed to do, normally. But the moment it is factorizable, do the needful. And you know those that are factorizable. Using that concept of sum and product. Those are things we've been doing in polynomials, and we did them. Something like 5x plus 6 x squared, or x plus 4 x squared minus x minus 6. You see that? The things we have been doing, very easy things. This x can even be a plus, can have 2x there. This x can be a plus, and this can be a negative 3. All those things. How do you know that they are factorizable? You check the sum and what? You check the sum and product. The moment these two things are in position to give you factors, then it is factorizable. Of course, you know that factors are those two which when added give you the sum, and when multiplied give you the what? The product. As simple as that. But the moment the factors are not coming out, like this one here, these two, there are no factors here. Like we don't have any numbers which when multiplied give you 1 and when added give you 1. Those ones don't exist at all. Never. They don't. So hope you now get it. Yeah? So this is a question that we were given. So back to the question. Let me rewrite the question as we hear from Gloria. Yes, Gloria, unmute.
Yeah. So thank you for the opportunity. But I just wanted to add on about the thing of factorizing and not factorizing. Well, our math teacher told us that actually those numbers, quadratics, you've told us that they are factorizing. Those the what? They are factors. Some of them are complex numbers. And so as we are doing that, we have to consider that the factors that we are having, they are integral, like they are integers. That is to say that if you're to find out whether the factors you're having using a calculator, they're giving you either decimals or whole numbers. And in addition to that, because in most cases, it us that to prove whether you have factorizable things or not, to use a calc. And if you press these quadratics that you've given us, when you press them in the calc, they give us the what? The complex factors. So the thing I just wanted to add on to let others know is that the factors that you're using should be integral, like there should be integers, not any other thing. Thank you.
Thank you so much. Hope you've heard. There is what they call the discriminant. We'll talk about that in quadratics. When you check this syllabus book, just here on top, just here on top before the code, before I seeing this, there is this topic called quadratic equations. She has been talking of how to use the calculator to know when and when not you don't have factors. And the thing she has been talking about is called the discriminant. And I think it is here. And it is used to verify the nature of roots. That's why you have been hearing her saying the roots should be real or integral, but you should not allow complex roots. But that's the language I'm supposed to use in this topic. But you like it or not, for partial fractions, they'll give you things that you can clearly extract the sum and product and the factors very fast. So failure to get them, you simply do the needful as I've said. But concerning the statements she has been saying, we shall look at them in quadratics, and it will be in revision form because quadratics are not disturbing so many people in the country. Those ones are kinda okay. So hope you get it. So back to the question, that was the question. So just like you can see this question, the sum is 3. If you can see, sum is 3, then product, sum is 3, product is 2. You see, you can easily get factors. Two numbers you add and get 3, but when multiplied, you get a 2. Very clear that it is 1 and 2. That's what I've been saying. So you can first consider the numerator and factorize it. So you first consider and say x squared plus 3x plus 2 is equal. We have agreed the factors are 1 and 2, that is 1x. Then this is 2x, this is plus 2, yeah? So these ones have replaced our sum, yeah? So I'll come and say this is x into x plus 1 plus 2 into x plus 1, just like that. So you end up finding out the x squared plus the 3x plus 2 is this. Hope you people are aware that when you always come up with this and this, since they are similar, we converge them into one bracket as we are factorizing, isn't it? Hope you people are aware. So why I was telling you that when you see something quadratic, especially when it is a denominator, way to judge it. What do I mean by judging? Way to just do things as the way they are supposed to be. When you just get the LCM and just put things together like this, it will not be wise at all. Now, why are we doing this? When you look at now these two questions, this one has been now converted to something like this. It has been converted into x plus 2, then x plus 1. Now, to make matters worse, hey, this one is already here. I've seen this one was separate on its own before everything was done, and it had its x plus 1 as the denominator. This denominator was given to us, but it was quadratic. So after factorization, it came out. You understand? It came out to have x plus 1, which was already present here. So when you're getting the LCM for this, we shall go back to O-level things. And I'm going to educate you, don't worry. So now this thing looks like this, eh? So in actual sense, the question changes, yeah? From the 3 over, is it 3 over? Is it 3 over? It is 2x, 3 is the other side. It is 2x over, this is x squared plus 3x plus 2. We are completing the topic today. And by the way, we are done even. So in actual sense, the topic is like, sorry, this denominator is supposed to be written like this, x plus 2, x plus 1. Plus, this one is 3 over x plus 1. Now, this is the real question. That is the real question. Now, someone may be like, but you told us to get LCM, you just simply multiply since they are unknowns. Why don't you just do that? When we just do that, realize then the LCM is going to be very weird, and which is something that has not been called for. So what are we going to do? Do you people recall this thing? I want you to recall. They used to tell us find the LCM of 24 and 36. I don't know if I still recall the procedures. I used to teach primary 7. I used to teach primary 7 20 years back. I don't know if I really recall these steps, but if I may try, put here 24. Let me see, put here 36. I put here 2, then I get 12, get 18. Put here 2, get 6, get 9, isn't it? Put here 2, get 3, get 9. Put here 3, get that. Put here 3. Then here, remember we are putting 1. So someone remind me. What do we put here? Now we are going to see those people who went to good primary schools. What do we put in that car box? And what do we do after to get the LCM? We put 1. Then what do we do to get the LCM? Hey, people, you're good mathematicians. So we used to say like this, isn't it? And then we used to conclude and say that the lowest common multiple is 8 times 9, which is 70 what? 2. Oh, yeah, I'm right. Okay, so I now want to put here a note here. So you people are aware that the number that we used to put here was a number that could, first and foremost, a number that could divide any of them. That's what we used to prioritize. You can first begin with a number that handles both, then maybe later on you can bring a number that maybe handles one and not the other. But the note I really want to give you is very simple. That when you look at these two, they have something in common. You get? And what is that something in common? Is this x plus 1, x plus 1? Just like here we brought a 2. We brought a 2 because this 2 has common to 24. The 2 has common to 36. In that it could divide all. So they had that in common. So even these denominators we are dealing with, even when they are unknown, I want you to always apply this concept of primary every time you're confused. But you only do it for denominators that have something in common. If the denominators have nothing in common, I assure you, that thing is not going to work for you. So we are going to use it and get the actual LCM. I want you to understand why the other method of just their product may not work for this case. Yeah? So when you come and draw your table, so this first one is here. We need LCM is x plus 2, x plus 1. Then the other one is just x plus 1. So to divide, I'll begin with the x plus 1 because it is common, isn't it? Then here I'll remain with only x plus 2. Then here I will have 1. Then I'll bring x plus 2. Here I will have 1. You people said even here we shall remain with 1. And you are done. So when you come to get LCM using the same technique, you will have x plus 1, x plus 2. That's what I was interested in. If someone wants to really continue, then they'll get somewhere here if they do the algebraic steps. So that is it. So do you people realize that if at all for such denominators, if you panic and go for the other thing over, they are unknown, let me just multiply them. You can be even shocked that you may come up with the same answer in the end. But the mere fact that you used the very wrong LCM marking may stop there and it may not continue. So in the end of it all, you've lost marks. So I don't know if we are there. You people, are you getting this LCM? This count? because it is literally against what we had mentioned earlier. And I told you that it is in this very lesson where you're going to get it. So when I come and rewrite, when I come to rewrite, this is what I will have. I will have 2x over, here down we agreed, we have this. You can even rearrange and begin with x plus 1, whichever you want. So the thing I want you people to note is that the LCM here is just this. Because of what I've said, that every time they have something in common, maybe after you factorized, use that primary method, that method of primary. It can assist you. But the moment you use that method of primary 4 times, the technique will go in your head and you will not need to use it again. You just look at both of them and be like, since x1 is common, then the LCM will just take the other one. Yeah. So, same thing. Divide this. So I want people to tell me whether they have gotten the reason why, because when I multiply those ones, this is what I will come up with. And maybe someone may decide to write this as squared, x plus 1 squared. So I want someone to confirm with me whether they have understood as to why the LCM is this and not this. Like, why isn't it like this? This is x plus 2 and this is x plus 1 squared. We have said this is not okay, but this is okay. Yet we are the same people who said for LCM of unknowns, simply multiply them. So I don't want you to be people who cram math. So I want people in the chat to tell me that it is okay. It is okay you understood the product part, and it is okay you've also understood this anomaly. You are over 70 people, so I expect 10 comments. You people, you are too many. You are too many, so I don't expect people to be quiet. It's only 4 people out of 70 people. Is that really fair? You people, this is what is going to dominate in the topic. If you don't get this, then never. Okay, people are now 10, and that is okay. That means we are good to go. So I'll remove these wrong things. Okay. So I'll come, you all know, when you divide this by the whole of this, you get 1. So 2x will be left alone. Alone. What else? When you get this, divide it by this, you get x plus 2. And so, because this one will cancel. So you'll have something like 3 into x plus 2. So here you'll have plus 3, then here you'll have x plus 2. Something like that. I assure you the rest of the things are easy. This is the hardest in the topic. So do you have here? You have 2x open brackets. This is 3x. This is plus 6 over this. If you want, you can leave it like this, or you can decide to even go back. So you come and finalize. You see? The rest is just collecting like terms, but it is the concept that you need most. Or someone can decide to go back and also write that one in this format. This is pure math, very flexible like organic chemistry. The problems in chemistry and math, it is physical chemistry and applied. People there are perfectionists. The moment you joke around, you lose marks. So hope that one is okay. You can see these people have their working. And I think they also have the same output as us. Yeah. Now, these things, you can find time and do them on your own. Because now you see this one. Can you really fail to do this? These are things we have just talked about. However, for them, they have a concept of multiplying 3 things at once. 3 things. Let me check this next example. You know, this one is the easiest. Because I taught you that this 3 over 5. I taught you in polynomials. It is 3 times 5. Even this is primary work. So you get 18 over what? Over 5. So it's what you handle. Though they are adding on some other things which are not hard. They are saying, hence all of this, of which it can also be solved. And I think after that example, the next thing is splitting. You see, the next thing is exercise, which you're going to do. But before I take you to the exercise, I want you to look at this. This one, this one, this one. Very important. Just want to talk about it here. So very fast, then we take the screenshot. How many screenshots have we taken so far? How come we are on page 4? Is it really possible? Did you take these 2 screenshots? How come we're on page 4 as if we have just started? Did you take those screenshots? As if we have only taken 1. So you take the 4. I told you after the classes, these screenshots can help you organize your notes. Of course, that is later. So this one is also 3. Okay, now let's continue with our page 4. This is Alice, you leave our screen. I don't know why people love playing with our screens. So very first, I want to look at this case 3, which has x plus 7, and then these are things 1, it is minus, x minus 1, it is x plus 1, sorry, something like that. So here now there are 3 of them. Remember I told you that it's not a must that partial fractions are 2. They can be 3, they can even be 4. So here you do the same thing. This one is 1. So these ones, there is nothing like quadratic, so don't over reason. So here you just multiply those 2. But this one is a bit hard. What makes it hard? That when you divide the whole of this by this one, you get that very one. So you're supposed to come and multiply it by x plus 7. So why I want to write this, I want to ask members, can you really multiply 3 brackets? Then other things can come after. What are those things? Dividing this by this to get this. So then multiply it by 1. So that one will multiply the x plus 1. You understand? A. Then in red, I get this. I divide it by this. I get this. I multiply it by 5. You understand? So somewhere I have my 5 multiplying the x minus 4 over so maybe this is what I believe. I believe people can handle this, people can handle this, but my emphasis is here. Can really people multiply 3 brackets? Because if those 3 brackets can be multiplied well, then I think we are done. If people can multiply those brackets very well, then we are done. Those 3, that's where my focus is. I don't know which strategies people use, but for me, this is what I do. When I have that x plus 7, I first put it outside, then I introduce square brackets that I first handle these 2 alone. That's what I do. There are 3 of them, 3 brackets. So I write the first one, then I first handle these 2. You get? A. This is x plus 7, those brackets. Remember telling you this is x plus 1 minus 4. This one is also x plus 1. Isn't it? I don't know that people know that technique. That's the technique I used to use. Back then, it used to work for me. First handle 2, then handle it with the 3rd later. And I continue. X squared plus x minus 4x minus 4. You see? Then after that, you do the same things. That each of the numbers in the first brackets will multiply the other bracket. Same things. So I'll come. X squared minus this minus 4. Even the plus 7. You know, if you people are aware of this, you need more space. So x will multiply that bracket. Even plus 7 will multiply that bracket. What do I get here? X power 3 minus, this is also power 2. Then this is power x, and this is power 2, then this is power 1, then this is power 0. Then I collect like terms. X power 3 is alone. Then when you look here, this is negative 3, this is positive 7, so it is plus 4. That, and so this is negative 4, this is negative 21, so it is negative 25. X minus 28. And that is the final answer. So I don't know if now people can handle any 3 brackets in mathematics. That's what used to give most people hard time. So is it okay handling 3 brackets? First handle the last 2, put them in square brackets. Now at this point realize When I had reached a step of using them, I transferred from a square bracket to a curved bracket. Why? I was now going to use everything. Yes. A square bracket just comes in to show that I'm now going to consider this first. The moment you've handled it now, you can bring back the curved brackets, do the same thing. Each of the numbers in the first should multiply the other one. I think I talked about this in polynomials for those who attended. So let me hope that you people will not find any hard time as far as multiplying 3 brackets is concerned. Is that right? Is that a deal? You people, you say it. I want you to confirm that you won't find hard time. You say yes, we confirm. You say yes, we confirm. Okay, hope it's okay. So you're having 4, -5 and -28. And these are the things that give people hard time in most cases. The things that give people hard time. So, you look here. Are you seeing this? That's what we have obtained. And those are the things that give people hard time. And trust me, when you follow up like this, all these things will be obvious. I told you that all things that need following up later, I want you to be very sharp. You take a screenshot, follow up later. Because these notes are only uploaded on our drive. You can never see them on WhatsApp. Yeah, I only put them on the drive. However, there are people here who have the books. Someone else may share, but not me. Because me, the ones I have are in parts according to topics. But there are people who have full books. You can share them, but not me. Yeah, me have the fear. Okay, now that one has been sorted. Now this one, I told you how it can be converted to 18/5. I think you can see here, it was converted to 18/5 by us. And also these people still use the 18/5. And they followed the normal steps. You can see it was 5 and x plus 7. LCM, they just multiplied. And you know all the anomalies, so they came up with this. But these people said, please and please, hence solve this equation. Are you seeing that equation? They wanted it to be solved. But these two were converted into a single fraction. Which single fraction was this? You get, so how it proceeded, this one was connected to 5 minus this. Now I push this to solving equations. This is now solving equations. This is now another topic. But this is something even a senior kid can do. That senior kid is very serious. Because you just multiply, do things of algebra, make sure all your calculations are right. If you're getting a quadratic equation, get it, then solve it using bulldozer. We used bulldozer last holiday. Those who review our lessons of last holiday, you see how we use the bulldozer, even factorization. So literally solving quadratic equations is the easiest thing ever. You see? You can literally follow up these things. So a serious student has taken the screenshot and will follow up later. And will ensure that they have understood how x equal to 3 was obtained and how that one was obtained too. So you be bright students. Everything I expose on the screen, find time, screenshot. After the lesson, organize your work and everything. So the next thing is exercise. I told you with this topic, I'm not going to panic. Because by 11, shall be done. Yeah? So you take that. This is your assignment 1. Assignment 1. Yes. Assignment 1. Keep it well. So target 1 is done. All people have taken the assignment. So when I check our syllabus book, we are done with target 1 in the first hour and a half of the lesson. So in the other 1.5 hours, let's also accomplish the target 2. Yes, so this one is done. That one is done. So now what are we going to? Getting now partial what? Fractions. But trust me, whatever we have been talking about is what we are going to apply. So they are saying there are basically four different types of algebraic fractions which can be expressed as partial fractions. What are they saying? They are saying we must check whether the values obtained are true by either getting the LCM to go back to the original fraction. Do you get? They are saying that after you splitting things into partial fractions, you can test your answer and be like, what if I get these two partial fractions and try going back? Do I really go back to my question? Do people get it? That the question has been split, the single fraction was A, and for you, you've gotten B plus C as the partial fractions. So to test your answer, you can literally add these ones and see if you can go back to the same question, or you substitute for any value of x on both sides. You put the value of x in your single fraction, put the value of x here, put the value of x here, try to add them. Check the result here, check the result here. If they are the same, you're good to go. But of course, we shall have to prove that, maybe in our first example. But I think people are getting it. A case in point, I want you to look at this example I'm going to expose on the screen. I tell you what these people have been saying. This is what they are saying. Let me get another example, maybe this one. Now, are you seeing this example? It had these two partial fractions. It had this one and this one. Now, what we are going to handle next, what we'll be doing, or for us to prove this answer, for example, we put here a value of x, we put here a value of x, subtract them. Then the answer we get, we keep it somewhere. You understand? Then we also come and put here a value of x and see if we shall come out with the same answer. That's how we confirm that what we have been doing is right. I don't know whether people finally get it. Because we just compressed the other two into one. So putting there a value of x, provided it is the same value, it should be giving us the same result. As simple as that. As simple as that. The other thing of trying to go back, I'm going to show you that. It will be understood well when I handle this. So, this is it. So, in our notes, I'll come and say target 2. Okay, sorry for that break. I was picking a certain call. So we are now going to split partial fractions. So I'll have target 2. So in this target, we are going to form formation of partial fractions simply mean converting a single fraction into partial fractions. That is it. You can say either forming or convert or split. Someone can say split or so this is the most important note as we are splitting. So we are going to note that the partial fractions dealt with are different. The partial fractions is the most important statement in the topic. The partial fractions dealt with are different. The partial fractions dealt with are different. What is this difference? They have different denominators. They have different denominators. They have different what? Denominators. So someone may ask, what do you mean by different denominators? Now you people, I remember teaching you polynomials, and you know what the word factor means. So by different denominators, I mean these different denominators also have different factors. You people, you know how factors look like, eh? Have different factors. And what do I mean? Some factors are linear. You get the point? Some factors are repeated. What do I mean by linear factors? This one I taught you in polynomials. Linear, they are of this format, isn't it? Whereby it can also be ax minus b. What do I mean by repeated factors? By repeated factors, they're of this format, power n. Here I can have examples. Maybe you have x plus 2. Maybe you have 2x minus 3. You get? Those are linear factors. Repeated factors, maybe you have x minus 2 power 2, but it's not a must that repeated is only power 2. We can have x plus 1 power 4 there is someone who may decide to write this as 1 plus x, but for you know it is x plus 1 power 4, or it may be something like 2x minus 5 power 3. You understand? That's what they mean by the term repeated. That this x minus 2 is repeated twice. This x plus 1 is repeated 4 times. This 2x minus 5 is repeated 3 times. Then the other factors, lastly, can be quadratic factors. Yes, and you should put it you should put it right that the quadratic factors we are meaning here, they are non-factorizable. And I told you what this means. Non-factorizable. Yes, you cannot factorize them because you have realized, but I'll show you that later. Non-factorizable, what do I mean? Something like x squared plus 2. You cannot factorize that, so it is purely quadratic. Then you can have x squared plus x plus 1. It is in the format but can be factorized. 5 minus x squared, you get such things, and etc and etc. So you people, when you look at something like this, x squared plus 5x plus 6, for example, where does it fall? If someone can tell us where it falls, then you've understood. Who can tell us? Where do you think that falls? X squared plus 5x plus 6. Assuming it is a denominator, Assuming it's a denominator, where does it fall? This is what people are saying in the chat. People are saying quadratic. People are saying quadratic. Hey, people, you are wrong. It is linear. Hey, anyway, you learn this. That's why I had to mention it here. You people know when you look at that, the sum is 5. Hey, I always feel happy when, because I had ignored this car thing. You people, it is linear. So after that, you can at least appreciate. We say that for you to call the denominator quadratic, it must be non-factorizable. It is still here on the screen, like purely none, but this one can be factorized. And when we factorize this, clearly, you can see the factors 2 and 3. So you have x squared plus 2x plus 3x plus 6. So I have x into x plus 2x. So you plus 2, 3 into x plus 2. So what do you get? Get x plus 3, then that. Are you seeing that? So don't you see that they are linear? Don't you see that they are in that format? For quadratic, they should be non-what? Factorizable. So let's take a screenshot of page 4 and page 5. I think no one reminded me to take that of page 4. Yeah, people, things are not easy, but this topic is easy. We are done. You just be patient for more 15 minutes. Because now we have handled the weirdest part of target 2. Target 1 was done. So I want people to give me assurance in the chat because most of you are saying quadratic. So I want all those people who are saying quadratic, give me assurance that you've understood why that one is a linear factor or a linear denominator, but not quadratic. Yes, it's in the quadratic format, but it is factorizable. And when we factorize it, we get linear factors. But if the quadratic thing can't be factorized, then we consider it to have quadratic factors. That's what we say. Quadratic factors. That's what we say. Quadratic factors. Quadratic factors. It's only one person telling me, yes, doctor, yet so many of you are saying quadratic. So is it okay now when I say it is linear? Do you pick that, people? Do you pick it when we say linear for that? Okay. So now we are going to handle these things in bits here. Let me tell you, with these things of partial fractions, I'm supposed to just do an example only. When I do an example, the rest are the same. Provided you learn how the different denominators are dealt with, then the flow of the calculation does not change. For the case of the flow of calculation, it is the same throughout. So I'll come here and say that we are dealing with type 1, which type 1 is for linear factors. So we are going to deal with the denominator with linear factors only. And this is the easiest. How do we split? Only linear factors. Okay, they are saying each linear factor, I think how it looks like, has a corresponding, this is where I want you to learn. Each linear factor of this format, so you know this format. So wherever there is that format, don't bother. But what are they saying? That each linear factor, this is the rule, each linear factor, as we are splitting, remember what we are doing is to split. So here they are saying express this into partial fractions. You're going to form fractions in parts. So this expressing thing is about splitting. So they are saying as you split, each linear factor has a corresponding partial fraction of this form, where this A is a constant. Remember, you already know the A and B. I taught that in polynomials. But I'm focusing on this capital letter A, which is on top. They are also saying it is a what? It is a constant. And that is the simple rule. And that is the simple rule. Nothing else. You people are aware that linear factors, all of them look like this, according to what we explained in polynomials, where that plus can be a minus. So they are saying that each linear factor has a corresponding partial fraction. So the question is, what is this corresponding partial fraction? That each linear factor has a corresponding partial fraction. Remember, we are dealing with denominators. So the linear factor will maintain its denominator and it will be in its position. But since we are splitting, as we are splitting, we give each linear factor a numerator like that, which this one is always a constant. So if there are others, we give them other letters, letter B, letter C, and they are capital. That's what we usually use. Why capitals? Because we just assume that the linear factors have taken on the small letters according to their format. So after we have obtained the value of A, the whole of this is what they call a partial what? Fraction. I remember telling you that math looks so weird when we explain it using unknowns everywhere. And it is best understood when we start the hands-on. When you use real values, real questions, well explained, and then you do a lot of practice. That's how math is supposed to be passed. Okay, so when I come and do the very first number, so I'll come here and pick our first number, this very one. I want us to do this. On top we have 7x plus 8. Down we have plus 4 minus 6. So the question is saying express, but me have said it is the same as what? Splitting. And what are you splitting? You're splitting something like this, 7x plus 8. Then down we have plus 4. Then you also have minus 6. So what is really happening? You're splitting that or expressing that into partial what? And this is where the problem is. Let us begin the splitting. I show you what we just said. They said that when this is like this, I told you there is when they use equivalent signs, but if you're not sure, please leave them. But if you're sure, you use them. So they said these are two linear factors. I want you to listen. These are two linear what? Factors. That means you are going to have two partial fractions. Each linear factor will have its own partial fraction. Each linear factor will have its own partial fraction. You see that? Each linear factor with its own partial fraction. Each linear factor with its own partial fraction. Now the thing is, what are the numerators? So we agreed that numerators will always be unknowns, and they will be constants, and we shall always use capital letters, preferably A, B, C, D, E, and so on. You will never reach F. The hardest number I've encountered ended at E, and you will see it also in your assignment. People, this is the most important thing. When you don't get this statement, then the rest of the thing, it is time wastage. This is the stem. Because when you reach this step, now we repeat the things we have been doing before. You understand? Hey, but when you don't get the stem, then you cannot understand anything. Don't mind about these equivalent signs. These ones mean that this is identical to this. But in case you forget them, you use your equal signs. They may bear with you and ignore that. So people, you give me a next. You tell me the stem is okay or the stem is not okay. But before this, you say the stem is not okay, let me pinch for you the screen and read those statements above very well, because everything has been explained. So when people are going to tell me the stem is okay, stem is okay, stem is okay, stem is okay. Only one person has said it's okay. What of others? You people, is the stem okay? Because it is the stem that is going to... Okay, the stem is everything in this topic. Without the stem, then our partial fractions they are nothing. Because the next is normal algebra. Someone is like, it's okay, but why 3 lines for the equal sign? Put the equal sign, it's okay. Someone is like, but do we only split with plus sign? Yes, we use plus sign. Here you're supposed to put plus. But in your calculation, you may get b as a negative. So when you get b as a negative, then it becomes a negative. But in the stem, you use a plus. If b comes out as a negative, then this one will also become a what? A negative. Yeah. That is understood. Now we proceed. I'll come and say, this one is 7x plus 8 over, this is x plus 4, this is x minus 6. You all know the LCM for these two. They are different, nothing is common in them. So I can strongly say the LCM is their product. Then here we shall have, if we divide and multiply, this is what we shall come up from. That's what we shall come up with if you have been following. You see that? Then I want you to realize that this one is the same as that. The denominators are the same, isn't it? And you like it or not, the cheat code is always here. Those LCMs should be the what? The same. Those two should be the same. Should be the same. After confirming that they are the same, ignore them. After understanding that they are the same, what do? We ignore them. After ignoring them, what do we do next? Equate numerators. Equate what? You get it? You said the stem was okay. The next step was normal algebra we've been doing. Left hand side was maintained. Right hand side was handled mathematically. Then we noticed that the denominators are the same on both sides. And I've put for each cheat code that they should be the same so that you ignore them and concentrate on those on top. How do you concentrate on those on top? You equate them. And after equating them, the mathematics proceeds. So that is the cheat code. So how do we consider or equate the numerators? So I'll put here my 7x plus 8. Then I'll put those 3. Oh, you people, you can put your 2 lines. But at this point, things are still like that. I don't know whether we are together, people. Do you realize that the denominators, which are the same as far as the cheat code is concerned, have been ignored and we have equated the numerators? Now here, the next thing is the hardest. Okay, the easiest. So are you people together with me at that step? Let me see. I don't know if people can see this. Anyway. Okay. Are we okay there equating numerators? Let me see if I have someone at least. Okay, we are together. Okay. Now we are saying that's what we have. So remember, we are supposed to get the value of the constants. Remember, they want us to split these things into partial fractions. The partial fractions are here, they are ready. This is one partial fraction. This one is another partial fraction. The only thing that is making them incomplete are these letters A and B. So in our calculation, we just need to find the value of A and the value of B. When we get the value and the value of B, we have the partial fractions and we are done. We have the partial fractions and we are done. Okay, so I'll come. Before I tell people what is done next, are we okay up to that step? You all know that we are looking for the value of A and we are also looking for the value of B. Hope people are aware. So I want to teach you the technique they use to get the values of those. And the technique is the easiest here. Oh, someone wants a screenshot. So I'm going to teach how those, but you are lying. The page is still on. What do you want a screenshot for? The page is still on. Okay. Now, we are looking for the values of A and B. We are aware so that the partial fractions are complete. So this is what we are supposed to do. If we want to get A, we first eliminate B. Give you another cheat code. To get the value of A, you let a value of X that eliminates B. Are you seeing that, people? That for you to get the value of A, make sure you substitute a value of X, or you let a value of X. Here we just let things. Or you know me, I usually use the word set, but wherever you either say set or let, whichever you want. So I'm going to ask you people, which value of X can you put here? Remember, you want to eliminate B. So you're supposed to substitute a value of X, which is going to remove this B. So you're not supposed to get a value which is going to remove both. Because when you get a value that removes both, then it is quite absurd. And it is not usually practically possible. It is very rare. So I want people to tell me, which value of x can you put there and the b is eliminated? Remember, you want to eliminate this value of b, eh? So we shall concentrate on this x, this one, because it's the one in charge of b. So which value can you put there and the b is eliminated? People, you be good mathematicians. You see -4. When you put there -4, -4 plus 4 is 0. 0 times b is 0. So b is eliminated. So you come and say let or set. So I'll let my x to be negative what? -4. So I'll come. This side I have 7 into x, but x is -4 plus 8. Then here you'll have a into x, which is -4 minus 6. Plus b, which is b into x, which is -4 plus 4. This is -20 if you have a calculator. This is -10a plus 0. If they even want to see everything, you can tell them b into 0. Or you just put there 0. Everyone is aware. So using good math, our value of a is a what? Is a 2. So we now have the value of what? Value of a. Now to get the value of b, we do the same thing. Now since we need the value of b, let me edit it in red. First to get the value of b, we are supposed to eliminate x. For us to eliminate x, we use this. Sorry, to eliminate a, we use this x as a suicide bag. So which value can we put there and a is eliminated? Remember now the value of a has been obtained, it is a 2. Now we need the value we can put there to eliminate a such that we get the value of b. 6. This thing that is a so I'll say let 7x, sorry, we are letting x to be 6, So I'll say 7 into 6 plus 8 equal to a into, even when you know that a is a 2, you can even put there, no problem, because you know that here it's going to be 6 minus 6, and it will cancel. So here I have b is x plus 4, so here I have 6 plus 4. So here you have a 50 this side, then the other side it is a into 0, then this is 10b. So you finally get b as 5. And people, trust me, that is going to be the order of the day. If you people have understood the 2 cheat codes, then partial fractions are going to be the easiest for you. So before I conclude, I want people to tell me that the 2 values are okay. That is value of a and value of b. Just tell me the 2 values are okay, because we are done. Remember, we are supposed to split. Continue. Ignore denominator. Why? The cheat code, they should be the same, so we ignore. Equate numerators. After equating, another cheat code. To get a, find ways of eliminating b. How do you eliminate b? You make use of the x value next to a b, and make sure 0 comes in to eliminate the b. Get the value of a. To get the other one, tit for tat. You do the same. Just like that. Okay. So now we conclude, Are you seeing that the first partial fraction was the denominator was x plus 4, the other one was x minus 6, and on top you had a and b. So you can come and rewrite, and say the question you gave me, is 7 that plus 8 over this one was x plus 4, x minus 6. The first one was a, and my a has been a value of 2. Then down I had x plus 4 plus, here it was b. My b has been a 5. Just like you can see there on top. My b has been a 5. Then here down you have 6. That one. And that's what they wanted. I don't want you to doze. So you're supposed to tell me again. You're supposed to tell me again that the whole solution is now okay. As someone takes their screenshot. Someone wanted the screenshot so bad. I have a question. So if the number is negative, you change it to a positive while relaxing it. An assignment for us. The assignments are coming. Do not even complete them. Yeah, let's just follow our book. And we are done. See? I think these people also have the same answer. You see, these people even first got B. For us, we first got A. You see? Here they decided to use equal signs. Just use them, provided you know how these things are used. You do what you want. So are you seeing this one? We are now going to do this one. And I think after that one, it is exercise. So those who want exercise, you first concentrate and look at this one. So I don't want you to always panic when you see such. I don't want you to panic when you see that and be like, this one is done. That one is quadratic. The moment you handle it as quadratic, you're going to fail. Why? You have panicked. You first check if it is factorizable. If it is, you may find that when you factorize it, it gives you two linear things. So now these things become linear. So don't always make that error. So please first try to do what? First try your level best. Try your level best to always anyway. It is 9:34:14. This one is serious. Then down I have x plus 2. Then I have x squared minus 12. Like that. So remember telling you, before you do anything, before you judge, first find out what the sum is here, what the product is here. People, for me, don't give you time to make notes. That's why I try to be slow as much as I can, so that even people who are copying as they're understanding, they can hit two birds with a single stone. Then those who feel the speed is high, or you will have to wait or depend on screenshots, something like that. So here the sum is -1, here the product is -12. So you all know the two numbers here, the factors, it is 3 and -4. Isn't it? When you add them, you get -1. Multiply, you get -12. Primary work. So this is something that can be handled. So you can first put it into consideration. So you tell the examiner that equal to, you get, anyway, let me not panic. Tell them that here I will have my plus 3x, my minus 4x, my minus 12. Isn't it what we have? So now the question will change. So the question will become, if you look there, have our 9x squared plus 34x plus 14. Then down, what do we have? We have x plus 2, and that quadratic thing which has been worked on like this. So there are people who prefer you to first rearrange the denominator. You can decide to put the denominator in order. Maybe you begin with x minus 4, then x plus 2, then last x plus 3. But those are all the same things. But what did we say? So here I'm not going to use any equivalent sign to confuse you. I'm going to use equal signs throughout. So we have said when you're dealing with linear factors, each linear factor will have its own partial fraction. So don't forget to put the linear factors down. The first one is x plus 2. The other one is x minus 4. The other one is x plus 3. So there, in the first option, I used brackets. Here I've not used them. That's how flexible math 1 is, or pure math. So, you know that when I split, I'm supposed to put constants on top, capital A, capital B, capital C. They are the preferred letters. The moment you do that, they will give you your marks. Because that is very important. First things first. First things first. So you people are aware that we've not changed the question. Yes, it is still the same question, just because we have just tried to replace this with whatever we have replaced. But trust me, it is literally the same thing. Question has not changed. Now, after that, you are all aware that we are supposed to rewrite this thing here. But now here we are supposed to squeeze, because whatever is coming next is serious. This is 34x plus 14 Then this one is x plus 2, x minus 4, get. Now, mathematics starts. What is the LCM of all those? They are individual, none is similar, so their LCM is just a product. And after considering the LCM to be a product, the denominators turn out to be the same on both sides, and that is the cheat code or the shortcut. So we begin the math. When you divide the whole of this by this, you get these two. Also, the whole of this, divide it by this, you get these two, if I'm not mistaken. Hey, that's what I'm going to write. So I'll come and write here my A, and I'll write the other two. That is x minus 4 and x plus 3. I proceed. When I divide this by this, I get this and this. I just get the balance. So I'll come and say plus b, then I write those two. Those two I have x plus 2. I also have x plus 3. I remove. We proceed. When I get the whole of this, divide it by this, I get these two. And so I come and write plus c and those first two. And you people are aware the moment the denominators are the same, ignore them. After ignoring them, you come and rewrite everything. Squared plus 34x. Now I want someone to unmute. We do these things together. We get the values of the three unknowns together, because they are serious. Yeah. You see this number? It's not like the previous one. This one is very long. And when you do this one, you can do that goes up to D. You can do that goes up to E. Now, what if we want the value of A? Now, when we want the value of A, we are supposed to eliminate these two. And we really thank God that these two have something in common, which is this. Are you seeing? That means when we make use of this x value, we can eliminate both B and C, and we shall of course get A, because A doesn't have x plus 2 anywhere. You know, the people are seeing the trick. We want to get the value of A. That means we are supposed to eliminate B and C. And by good luck, B and C have something in common, which is x plus 2. So that means if we play with that x well, it can give us B as 0, C as 0, and then we get the value of A that we really want. I don't know whether people are seeing that. Are people seeing that? Do people realize that something can be done? Doctor, I thought ABC multiply all. I thought we use angle brackets. I don't know what you mean. Yes, they multiply all. Oh my, this is multiplication, yeah? With multiplication, you don't need. So, oh my, the statement you need is this, that in mathematics, ABC is the same as A, B, C, it is the same as A, B, C, because it is mathematics, yeah? So whether brackets are where or where, but if we had division if we had addition somewhere, then those square brackets could come in, yeah? So that shouldn't stress you. So I don't know if people could realize what I've just explained, and that when we put -2, B and C will get eliminated, but A will remain in place. You people, do you see that? But when we bring X as -2, B and C will go, but we shall get the value of A as we want. So I'll come and X as what? X as -2. That's what we have agreed. So X as -2, I come, I say this one, -2 squared plus 34 -2. Yeah, you're supposed to struggle with the substitution. So this one is A, -2, -4, -2 plus 3 plus B, -2, even when you know that here it cancels. Plus C, -2 plus 2, -2 minus 4. Yeah. So B and C cancel, so remain with only A. So using a calculator, I don't know what I have this side. People, what do I have this side? My calculator is very fast, so I need people who are cooperative. What do I have this side? On the left, what do we get on the left? People, what do I get on the left? Anyone? What do I get on the left? -18. Then here my A, -6. I think it is -6. Yes, so here I'm getting my A. Here I'm getting my A as 3. Very correct. 3 looks correct. So again, when I look at, now when you want to get B, let's assume you want to get B. When you want to get B, this one, you're supposed to eliminate A, you are supposed to eliminate C. And by chance, these two have this in common. I think X minus 4 is common in the A and C, which we are supposed to eliminate to get B. And B doesn't have that X minus 4. That means we are going to let our X to be what? Any good mathematician to tell me what X is going to be for us to get the value of B? That's what people are suggesting in the chat. 4. Exactly. So we shall set our X to be 4 so that we come 9, 4 squared. Yeah. So wherever we had put -2, we are going to put 4. Yeah? So you can follow up. 34 into 4, those of calculators get ready. Plus 14 is equal to 4 minus 4. So people, here I've not put these zeros, plus B into 0. You can even just say plus 0 because it is clear. So anything is okay. Get it? Where are we? Wherever there is -2, we put 4. This one is 4 plus 3. I was using blue ink. Plus B. We are putting for non-negative form. Plus B, which is 4 plus 2, which is 4 plus 3. Then C, 4 plus 2, then 4 minus 4. Yeah. So what do I have on the left? What do I have on the left? Now that is 9 times 16 plus 34 times 4 plus 14. People are saying 294. Is it right? Okay, 294. Thanks, people. So my A is a 0. 6 times 7 is 42B plus another 0. So according to math, my value of B is a what? Is a 7. And I've passed. Even 7 looks correct. So when we go back to our general, so do you see, people? By the way, this is the technique you keep using. Yeah, of getting these constants. You people said that the stem is now okay. So when you understand the stem, the other things are the same. So the next hard thing to understand is the stem of other denominators. And trust me, when you crack that, and I told you we are going to respect the curriculum. We are going to respect the curriculum so much that I will always be leaving something little for you. I will be leaving something little for you as research. I don't know what I should leave for you. Why leave for you the improper? I think I'm going to leave for you the improper. I'm going to leave for you the improper. After all, the improper has these things to come in later. So improper is yours. So if improper is yours, that means we are concluding the lesson in the next 5 minutes. If improper is yours, in the next 5 minutes, the lesson will be done. So when you look at that, we are now missing the value of C. So you are all aware that if we really want and crave for the value of C, we are supposed to eliminate the value of B, we are supposed to eliminate the value of A. Get the point? Yeah. Eliminate the value of A, eliminate the value of B. And we thank God that they have something in common, that the two things we want to eliminate, they have something in common. So this X is the Judas Iscariot to assist us with everything that we want. So how is that Judas Iscariot supposed to act? To eliminate A and B such that the C is obtained? What will be that value of X? My mathematicians in the chat, you say that X value, we proceed. Hey, you are quiet. You say that X value to enable us get the value of C. -3. Someone is like, Doctor, what about using the coefficients? Even the coefficients are okay. If you know that method, you go with that. But since 2022, that method has been giving my students hard time. So I resorted to this because most of them liked this. So you let the X to be -3. So wherever we had 4, we are going to put -3. So we shall have 9 into -3 squared plus 34. This is -3. Those with calculators, get ready. Plus 14. This one will be A. Yes, Lorenzo. Yes, Lorenzo is -3 plus 3 plus b is -3. Please leave my screen, Lorenzo, if you can't speak. You remove that red line. Then C, we shall have -3 plus 2, then -3 minus 4, something like that. So you people, we now have just one day, Tuesday, for the free classes. Wednesday, they are going to be premium classes, and I'll miss you all. Trust me, one thing I can assure you, you may not, I don't know, but you may not get access to these classes. It will hurt me, but I will have nothing to do. That's what is supposed to be done. But at least make sure these free lessons you've had, at least they have had an academic change. Yeah, you saw that you've not remained the same at least. But starting Wednesday, so we only have tomorrow. I don't know what we have tomorrow. Is it chemistry? I don't know. Maybe I'll be introducing some new topic, maybe periodicity or thermochemistry. But it may be thermochemistry. Yeah. So I'll miss you people on Wednesday. But please, it's just 50,000 chemistry and math. So you pay and attend. Pay and attend. Don't miss. Access the drive, watch videos that have been already recorded at your own convenience, and pass. Get the concepts, go to school, let teachers repeat them, revise, and get the best results because it is possible. Yeah. So what do I have on the left? What do I have on the left? -7. Okay. A and B, those are zeros, so I can have A into 0, have B into 0. Then this one is -1, -7, isn't it? -1, -7, making it 7C. And then my C comes out as -1. So someone had a question about this, that what if one of them comes out as a negative? Here it is. Remember, here it is -1 as C, but in our general or in our stem, we had a plus before C, and that's how you simply make it a what? A negative. So after getting these values, you now go back to the original question and write the things like how they are supposed to be. So you come and conclude and remind the examiner that your question was 9x squared. Here it had 34x. Here it had 14. I don't know if we had the screenshot, but at least I know we are safe. The good thing, we got the values and people have been following it. People, remind me of those values. The value of A, the value of B. The value of C, I recall it is negative that. Here it has been 7. What was the value of A? So the question was 9x squared plus 34x Please, Mayamba, you leave our screen. So here I think it was x plus 2 then x squared minus x minus 12. What was the value of a? It was 3. Okay. So you come and say 3 over, this was x, what's that? B, 7 over. What was the next there? Was it x? What was the next denominator there? Then this c has been minus 1. So this is how we write it. So you don't say plus, then numerator has -1, no? You simply say minus 1. What was the first denominator? Okay, what is the denominator below 7? Those who have been writing. What is the denominator below 7? And what is the denominator below -1 or below 1? Those who have been writing. Anyway, let me check it here. I still have that. Those people have now refused. Let me check it here. Where is it? X minus 4x plus 3. So this one is x minus 4, then 1 we have x plus 3. And that is the answer. So do you see that? After getting the values, you simply now come back to the original question or to the stem and substitute in the stem. So it's all about substituting in the stem, and that is all. So is this question also okay? People, is this okay? Because you know after that question it is exercise, eh? So you need to give me a genuine response. So you can see this question, these ones have, are you seeing this answer, eh? Theirs does not look like ours, but trust me, what they have below 3 is what we have. What they have below 1 is what, like this. And these signs, before 1 it is minus, before 7 it is plus, below 7 it is x minus 4, below 1 is x plus 3. And there are those things we have, yeah? Just because the order may be different, but the thing comes out. Yeah. Okay. It's okay. Okay, people, I told you. Okay, first copy this first assignment. This is actually the second, yeah? If I don't want to come back here and talk about partial fractions, no? So you people, you handle this. They have even given you the answers in brackets. That's why I like this book. It gives those answers in brackets, eh? Then our next thing is this one, type 2. Denominator with a quadratic factor that is irreducible. So here they said irreducible, but for us we have been calling it non-factorizable. After you realize that the factorizable one can be dealt with. So here it's for only the non-factorizable. Non-factorizable. Okay, hope the screenshot is done, yeah? So very fast about the irreducible one. Things are very easy. I always advise you to make notes from this. So you're now going to talk about a denominator. By the way, now these remaining things are very easy. Here you just need to understand the stem. When you understand the stem, the other cheat code of getting constants is the same. If you want to eliminate this, if you want to get this, eliminate the other one. Yeah, that's what we are going to be doing. So here next on stage is going to be a denominator. And our denominator right now, it's having that irreducible. Or what we called non-factorizable. Irreducible. What I called non-factorizable. Factor. Yes, it is a factor, but we cannot factorize it. Simple as that. Let's do the very example that is here. Or we can first have a note. We can first have a note and say, I want you people to recall, this. If I give you a note, you recall that if the denominator, if the denominator is linear, that was part A, you recall, yeah, that if the denominator is linear, the numerator of the partial fraction, is a constant. Now here, people who attended polynomials are going to enjoy. Isn't it that what we said? Those who recall that if somewhere you had the denominator as something like this, we said the corresponding fraction, the partial fraction was of this format. Isn't it what we have been doing before? And the constant I'm talking about is this. That's why I'm saying the numerator of the whole partial fraction is a constant. But it is a constant only if what? The denominator had a linear factor. Isn't it? Now things are a bit changing. This time round, our denominator is having something quadratic and it is irreducible. You understand? This time round, our denominator is having something quadratic, and this something quadratic is what? Non-factorizable or irreducible. And the format is ax squared plus b x plus c. What does that mean? Since it cannot be reduced, that means even when we reach this step of writing the partial fraction, even when we reach that step of writing the partial fraction, it will have the same denominator in the format. You know that people are getting me, but we are going to, of course, do a calculation. I just want people to see the connection. When it was linear, like what we have been doing, we have been calling a numerator a constant. But people are asking, what if it is quadratic and it is not factorizable? That means it's going to keep like this, even in the partial fraction. Because you cannot reduce it, you cannot factorize it. So you have no option other than forming a partial fraction with the same denominator. You have no option at all. But the thing is, will the numerator still be a constant? If when the denominator was linear, the numerator was constant, then what of when the denominator is quadratic? What do you think? What do you think for the numerator? What is it going to be? Those who attended polynomials. In the first case, the denominator was linear, degree 1. Hence, the numerator was made a constant, degree 0. Now in part B, the denominator is quadratic, degree 2. What do you think the numerator is going to be as we are forming the partial fraction? Let me see if people are good at comparing and reasoning. The numerator will be linear, even when someone has used the wrong language, but at least there is some sense that it will be degree 1. Yes, that in part A, denominator was degree 1. So we made the numerator degree 0, which is a constant. Now in this format, we are having degree 2 persisting, or we have quadratic. So as we are getting our numerator in the partial fraction, we shall make it linear, or we shall make it degree 1, period. And how is it going to look like? It will always look like this. Not always, but I'm just giving you the format of linear. You know linear is ax plus b, but we are supposed to use capital letters because small letters have been used already. So for us, we use capital letters and say ax plus what? Plus b. In case a and b have been used already, we go for other things. Yes. In case A and B have been used already, we can go for Cx plus D, Bx plus D. Provided you follow that format of Ax plus D, even when you use capital Px plus Q, provided you use capital letters, because we assume that small letters are the ones appearing down. So that is the stem I was talking about. But how to get for the values of A and B? They are the same things, but the stem is really hard. The moment you fail to write the stem, that means all the following calculations are going to be very wrong. And when they are very wrong, it cannot literally work out for you. Okay, so people assure me that you're okay with the numerator that is linear, or you're okay with that change. I want around, the number is now reduced, so I just want around 5 people. Someone's like, do we use A and B only? Not only A and B. Anyway, these are just stories. These have been stories about math. Now let me now get an example. I know these stories are not easy to understand, If I narrate stories in math and you pick them, just know, yeah, you are blessed. And it is a very good gift. Most of the math is understood after a good number of calculations and examples. But these stories can seem difficult because I'm mentioning so many words: partial fraction, numerator, denominator, linear, degree one, constant. I've mentioned things of degrees and people have gotten confused. But at least you're sure we are dealing with a denominator whose factor is quadratic and cannot be reduced. At least you understand that. Then I do the first example. Are you seeing now? What if, just imagine you were teaching yourself and you were reading this book. This book just says, for each quadratic factor that is irreducible and non-factorizable, has a corresponding partial fraction of this form. At first we had these, we had partial fractions of this format. You understand? This was degree 1. And this was degree 0. Maybe people are not getting things of degree 0 and degree 1. Then you are supposed to visit the lesson of polynomials. But if those words are difficult, you take here the word linear, then degree 0 is for constants, what they call scalars. So now we are saying, what if the denominator is a quadratic factor that you cannot factorize or you cannot reduce? Like this one. I see now this one. Now that one, the sum is 3, the product is 5. Are you getting it? Sum is 3, product 5. Those two numbers don't exist. Numbers which you add and give you 3, and when you multiply them you get 5, they don't exist. You understand? That means as we are coming up with our partial fraction, we shall have no option other than leaving it in the denominator. But when we leave it in the denominator, we are now having something. You look now here. When we leave it in the denominator, we are now having something in degree 2. This one in the denominator in that format. So to make sure that we match what we did first, we shall have to put something of degree 1 in the numerator. Someone was like, but do we always use that A and B? No. If you have already, you go for B and C. If you have B and A, you go for C and D. If you have C, if you have up to C, you go for D and E. Just make sure you listen to those words carefully. They actually flow. Just because there are too many unfamiliar terms in the same statements. But let's do the number. At least you understand the number. But that is it. I just wanted you to understand why we are having something linear in the numerator when down it is quadratic. And I've said it's because in the beginning when we had something linear in the denominator, the numerator had a constant or a scalar. I will not go beyond that. So this is the question. Let's handle it. Of course, we are going to begin with splitting. So example. We are going to begin with splitting. This is 7x squared plus 2x minus 28 x minus 6 x squared plus 3x plus 5 is equals signs. So at least you're going to get this. What are people saying in the chat? Anyone with a video of polynomials? Can someone access the video of polynomials? I think they are the words of degrees that are giving people hard time. You see, you're not following up these lessons in order, and it will surely affect you. Okay, so now let us split this. So we are having two. We are having, okay, the whole of this is what they call a denominator. At least that one, let us agree, that's what they call a denominator. Now the denominator is having two factors. This one is a linear factor, and you all know a linear factor must have its own partial fraction. The same denominator has this factor, which is quadratic, and the quadratic cannot be reduced or factorized because the product is 5, the sum is 3. Those factors don't exist. So that means it will also have its own partial fraction. And how do we feel? For this first one, it is x minus. You follow now. Those way are saying things are not clear. The other ones were stories. Now this is the real math. This one is x minus 6. And we said we shall always put here constants on top. You get? Because this one is linear, so we shall put here a constant. This is linear, we shall put here a constant. You people, by degree 1, I mean this highest power, this power on x is power 1. That's why we call it degree 1. And this a we call it degree 0 because it is the same as x power 0. Because x power 0 is 1, so it is the same as a. That's why we call it degree 0. You get? But at least you know linear, at least you know constant. Then when I come to this second factor of the denominator, which is quadratic, and it is x squared plus 3x plus 5. This one is quadratic, or degree 2. That's why even when you're solving for quadratic equations in the calculator, you go to degree 2. Why degree 2? Because of this highest power of x, which is a power 2. So here we have said it was degree 1 down, for reasons I've explained, and on top we had the constant, which was for degree 0. And I was saying, since this one is of degree 2 and it is down, what do you expect us to have on top? Degree 1, we put degree 0. This is degree 2, so on top we are supposed to put degree 1. And you all know this is the format of degree 1 according to polynomials. This is the format. Degree 1 because this x is to power 1. But I said we assume that down we have small letters and capital letters are supposed to come on top. And I've already used my a here. So here I'm supposed to begin with the b. So I write b x plus c capital letters. And someone will ask, why isn't the x capital? Then for your case is different. Because now why are you bothered about the x? Yet you know that with this topic we are supposed to get values of the constants, which are capital letters. So don't let other things bother you. Period. You people, is that hard? Now that's what they call the stem. And when you don't get the stem, I assure you cannot get anything else. Because the other things are the same. But the stem is what disturbs people most. The stem is what disturbs people the most. And with this quadratic, I just need to do a number because it is treated the same way. You notice a quadratic non-reducible? The numerator is what? Linear. Constants are capital letters, period. Where the denominator is linear, that one you've learned. On top you have constants. People, is that hard? You people, okay, you tell me where exactly is the problem? Problem, you people dodge lessons. Now you're hearing degree linear quadratic constant, degree linear constant quadratic, degree linear constant, what? People are saying no son, no doctor. What do you mean by no? You make statements that are clear. Like Gloria said, me, I got it. That is clear. When you say no son, no doctor, like what do you mean? Because I've even forgotten what I said. But if someone says it is okay, that is clear. But when you say yes, sir, yes, doctor, no doctor, what is that? You reply well. You say not got it, got it. Other than you writing other weird things. Okay, that is it. But you need to visit the lesson of polynomials. After all, around 5 people have said it is okay. So I will assume so. But I think these statements were important for people. Let me leave them. I remember even I gave you those what? How degree 1 looks like, how degree 2 looks like. So people, after that, the other things are the same. The other things are the same. Which things am I talking about? You come and rewrite this as usual. 7x squared plus 2x minus 28 over this one. Now here we didn't factorize anything because things are not factorizable. So you even thank God that the LCM will be the same. The LCM will just be the product because nothing here needs factorizing. So you're not looking for similar things. You're not going to use the other methods of primary. Like what for? You don't need them. Plus 5. Now you people know that when you divide the whole of this by this, you get this. So it will be a times this plus this. I don't know whether people get that. So I'm going to trap them off because they are clear. So this one will be a into x squared plus 3x plus 5 plus this, you divide it by this, you get this. So this one will multiply that. So what do we have? Shall have bx plus c multiplying x minus 6. Like that. And you're done. The most important thing is having a correct stem. The moment the stem is correct, nothing else is wrong. Now, do you see that the denominators are the same? I ignore them and equate the numerators. Then I start solving. Period. You people, make sure you don't go below 30. Make sure you maintain a number of 30. But I don't know I don't know the exact problem of people. People log on and later. Do people just have mood swings? Are people just tired of studying? Do people just get lost and decide to go off? Do people don't have data? Do people just know these things and are too obvious? This is x minus 6, like that. Oh, You people now, this one is serious. Hey, because if we want to get the value of A, we are supposed to eliminate the whole of this, isn't it? Which is okay, you can put here what? 6. So let's do that. Like if we want to get A, we are supposed to eliminate the whole of this. So we can make use of that X by putting there a 6. So I'll set, or you let X to be a 6. 6 squared plus 2 into 6 minus 28. This one is A. Now realize that inside you're going to have something like this. So you're going to use curved brackets inside. So I'll bring my what? Square brackets. So that I can use the curved brackets with peace. So 3 into 6 plus 5. I close with my square brackets. I bring them again. Be like this is B. And it's serious. Okay. Like this is B into 6 plus C. 6 minus 6. So the whole thing turns into a 0. What do I have this side? Those with calculators, what do I have the other side? What do I have the other side? What do I have the other side, people? Two, 3, 6. Then here I have 36 plus 18, that is 54, 59, eh? Then the other one is a 0. I think my A is a 4. A is 4, yes. Hey, people are calculating, that is good. Now, people, we have our A. How are you going to get others, the B and C? Hey, like, how are you going to eliminate those others? For me, I have a technique that I always use. You see, in case you are stranded, yeah? Like right now we are stranded. Why? B and C are together. Are you seeing that? B and C are together. So, do you see that when okay, 0 always comes in, let me just be direct. 0 always comes into sort of these things at some point, but not always. Do you people see that when I set my X to be 0, I will eliminate B? Do you see that 0 eliminates B? Because somewhere we have Bx. So in these things of quadratics, since we always have that thing of ax plus b, bx plus c, cx plus d, dx plus e, setting x to be a 0, we always do something. So never take it for granted. You get? So we shall let or set whichever I want. So I'll let my x to be a 0. The good thing with the 0, it makes work easy. It even reduces the values very fast. You can even use your head with a 0. So here, since I'm going to use curved brackets again, I'll bring my square brackets. This is 3 into a 0 plus 5 plus b into 0 plus c. This is 0 minus 6. Get the point? Now, you people, are you seeing this value of a? This value of a. We got our value of a as 4. So please remove a and put our value 4 because we have it already here. So it is even very clear that this side we only have negative 28. Here we are having 4 times 5, which is 20. Then the other side we have a minus. I don't know if I'm right. Don't we have that? Minus 6c. And according to the good math I know, my c is 8 because I'm seeing 48 somewhere. So I'm getting c as 8. So I want people to tell me that c is okay in the chat. It is not easy. But for these things of quadratics, I've said, because of that thing we always have, ax, bx, cx, dx, these constants touching the x, we use that chance and set x as a 0 so that it eliminates it very fast. So I want people in the chat to tell me that c is okay, c is okay. Now, do you see? We now know the value of c. So we can get the value of b. We can now get the value of b. No problem at all. The only problem in partial fractions is the stem. If you don't get the stem or you write the stem wrongly, all the other work is going to be very wrong. All the other work is going to be very wrong. So, since now we have nothing else to eliminate, you simply choose a curve value that is going to be easy for you. Yeah, you choose a curve value that is going to be easy for you. The value that is always easy is 1. And since we have not yet let 1 and we have no trick to use for eliminating others, we shall have to bear and set a 1, so that we just substitute for others. Let us set our x to be a 1. So wherever there is 0 in that one above, I'm going to put 1. So this one is 1 squared plus. So have you also learned that trick of a 1? A is a 4. Bring this. So we also know the value of c as 8. So I'll put it there. You understand? Then here we had our x as 1. So it'll be 1 minus 6, something like that. This side we have 9 minus 28. Oh, it's negative 19. Very weird. Here we have 9, we have 36. The other side, what do we have? We have negative 5b. And we also have minus 40. Finally, what do we have? What do we have? This is a what? These things are serious. This is negative 4. When it comes this side, my b is a 3. Are people getting a 3? You people, you can also use coil head. I don't want us to have a lot of steps. 36 minus 40 is negative 4. When negative 4 goes the other side as a positive, it becomes negative 15. Divide by negative 5 is a positive 3. Yes, I've learned the trick. Yes, learn the trick of 0, learn the trick of 1. You say 1 is easier to deal with, but you find someone very weird. Say, okay, let us set x to be 250. Yes, 250 is going to give you correct things, but why do you set that? However, me, I used to do them. When I was in senior 6, when I had mastered everything and I was just waiting for your name, such numbers, for me, it could be very, I say, set x to be 3.6 times 10 power 5, so that I use little space. Because this is very okay and it gives you answers. I first do with the one on the side work, then I bring a weird value, just to attract the teacher's attention. Then next time I say, let me now use natural log. Let's set x as len 3. This is also constant and it works. But why? Who are you proving? Just do simple work and correct work and leave everything to. So the values, we have 4, 3, and 8. So you go back and rewrite. The thing was, are you seeing they also have the same values? They have A as 4, they have B and 3. For them, they are comparing coefficients, which is something sensitive but also okay. Then they also have their C as 8. After getting them, you now go and conclude. And as you can see, the next thing is going to be what? Exercise. Yeah. So we are also going to, but you people, why do I need even to show you that final step? You know the step. Let me just put here the word conclude, yeah? Go back to the question, then substitute. Why do you allow me to waste a lot of time on obvious things? This is the conclusion, yeah? You go back to the question. You see now here he has used the equivalent, but sometimes he uses equal signs. So it is okay at advanced level. They don't over that. So as you can see, this is where we had the b x plus c. So b, they have put the 3, c, they have put the 8. This is where we had the a, and they have put the 4. The denominators, you know, they were just split. Why? This one wasn't factorizable, it wasn't reducible. That's what I told you, that with this thing, you just need one example. Because math doesn't change. The person who wrote this book had a lot of examples. After all, the exercise has a lot of numbers. But why he didn't waste time? It's because he knew that with quadratic things are very obvious. So you can take a screenshot for this. This is assignment 3. Let me first put for you the word assignment 3. Assignment 3, let me put for you this one. Yeah? You also do for me this one. Let's sing this one. Someone may say, but doctor, you are lying. That one is cubic. But then someone will say, doctor, you're lying. That one is cubic. You draw that. You dress. I mean, taking a screenshot for that. I comment about this. So when I come here, I'll give you a certain hint. These people have a tendency of hiding things. You can have 5 out of x power 3 plus 4x. Now, here your rule, at least I told you first try to factorize it. So you can see x is common. So when you pull out x, you're remaining with x squared plus what? Plus 4. So when you split, what happens? You come out with x, which is what? Linear. and then you come out with this one, which is what? Quadratic. Then you handle it the same way. You split. You have the first one, it is a over x, isn't it? Then the second one, since its denominator is like this, and is quadratic, it is bx plus c as the numerator. You people now, can't you handle this using the same steps? Do I really need to do another example? Do I really inbox me for the soft copy? What if I form simultaneous equations for C and B? That is also okay. And that is also okay. That is also okay. That is also okay. So I'm seeing someone called the one telling you to make sure he sends you that book. Someone is asking how much is the book. It is for free. Someone is just selling it online. So you can see that the thing is okay. I think we should do the last thing. You said, doctor, do the last thing. You say that, doctor, do the last thing. I told you this topic is the easiest. The last thing, of course, you know, it is the assignment. So this thing of repeated factor is the easiest, I think. Only one example was done, as you can see. Only one example. Then they put the exercise. After the exercise, what was put here was improper fractions. And improper fractions is your research work. Yeah, I told you we shall always respect the curriculum. Most of you are aware, your teachers are not teaching you these things. They give you groups, you make research, you present, they comment, and that's the order of the day. So improper fractions will be yours. You have a lot of examples here, and then at the end, you have the general exercise. You have this exercise, which you can also try out. Then you have the general one, the general exercise, all that. They even give you the uses of partial fractions, that is the application. You can also go through it, and then that will be the end of chapter, because the next chapter will be trigonometry. So you realize that before the general exercise, you have some work to do about these improper fractions. They are very easy if you attended the lessons of polynomials. But why I'm going to give it to you as research, because we have people here who dodge polynomials, so they need to visit them and later come for research. So this is the thing we are remaining with. Are you seeing? So I want people to be strong. Are you seeing where our research work is? So I'm supposed to just hint on this one of repeated factor. Then improper fractions is going to be our research work. So we are supposed to only go through this. And it is obvious. It's what we have been doing literally. It's what we have been doing literally. No problem at all. You know what repeated factors are. So I'm just going to teach you what happens. I'm going to just teach you what happens. So, so we are finishing the lesson in the next 1 minute. After all, what we are remaining with is not even a full page. So you can take a screenshot. Those who have been following, take a screenshot for that. So we are finishing our lesson in the next 1 minute. Then we shall call it a topic. and we shall call it a topic. So part C, we have that of repeated factors. As far as the denominator is concerned, repeated factors, and you know how they look like. So I just want to give you the technique. Here, the technique is very easy. This is the technique. That for example, if you have something like this, x plus 1 squared, that's what I'm going to do. I do for you. Three. And I also do for you. Then this one will be for the student. Okay, now this is what happens for these repeated things. This is what happens. So when you see squared, there are two. You understand? When you see cubed, of course, there are three. You understand? When you see quadratic or power 4, of course, there are how many? There are 4. And how are these 4 treated? So this one, this is how you do it. If there are 2, you first write it like that. X plus 1, x plus 1. Since there are 2, this one is to power 1, this one is to power 2. You get it? That's how they treat repeated factors. Because of power 2, partial fractions will be 2. So the first one, power 1, that's 1, power 2. If you want to get it, let's go to this one of power 3. Because of power 3, we said there are 3. So you write all of them. X plus 1, x plus 1, x plus 1. So because there are 3, this one will be 2 power 1, this one will be 2 power 2, this one will be 2 power 3. This one was also to power 1 just because I never put it, because with or without power 1, it means power 1, isn't it? Same thing with this one of power 4. You put all of them, x plus 1, x plus 1, x plus 1, x plus 1. Because of that, first one, power 1, power 2, power 3, power 4. So this power 5 is just obvious. Even if I don't pick, okay, someone to pick to tell us what is down. Okay, someone is going to say it later when all are done. So someone is asking, literally, what is on top? Because we have secured the denominators. What is on top are just constants. Capital A, capital B, capital A, capital B, capital C. Capital A, capital B, capital C, capital D. That's why I told you that with these partial fractions, the most disturbing part is the stem. Because someone may be like, but this one is to power 2. Isn't it quadratic? No. Is it in the form of quadratic? Are you sure? Can't you distinguish between this is squared plus C. Can't you distinguish it from this? They are different, eh? Very different. So quadratic is not the same as repeated. Hope I'm clear there. So I want people to tell me, are you okay with the stems of repeated factors? Or you need me to pardon? And if you need me to pardon, where exactly or what exactly is confusing? I need to know. If they're okay, I need someone to raise up their hand. You tell us what we have for that last one, how the stem will look like. Are you okay? Okay. Anyone raise up their hand to tell us what we shall have for that? Yes, you are the student, so I need someone to say something about it. Anyone? Yes, Moses.
So
Mm.
you can hear me? Doctor, you can
Yes,
hear
I
me?
yes I can.
Yeah. For this one, we shall do at the denominator. First, we shall have x plus 1 bracket power 1. Then at the next
I'm
part,
hearing.
have x plus 1 in the bracket power 2. The next one, x plus 1 power 3. Then it will be the same. Power 4, then power 5. Then up we put the constants.
Which constants?
So A, B, C, D, E, and the F. Yeah, and the F. Is it that one?
Are you sure F is part?
I'm not sure.
Then you are not easy.
So it is A. Sorry.
Yeah, they stop at E.
Yeah.
So, think you people can see, they have said that if the repeated factor is of this format, they even call it repeated linear. So because of the word linear, on top we should have constants, and I think you can see, and it's done. You see what they want? They are saying now express this in partial fractions. People, trust me, you don't even need me to do anything here. Let us go for the first time. Let us do this together. Like just going through this. I want to show people you will over complain. Because I know right now people have forgotten the other idea of long dividing. Sorry, of getting the LCM using the formats of primary. So we have this. Then down we have 2x plus 1. We have 2x. This 2x plus 1, then x minus 2. This is squared. So we are going to split. So how do you split? For you come and be like, Dr. Utaya said, when you see something linear, it has its own partial fraction. Then you proceed and say, Dr. Utaya also said that when we see something repeated, because of these two as a power, they are also two. Isn't it? Then you be like, This one, the first one, which was linear, to be just like that. And so, then this one that is repeated, we first write the one that is repeated like that. Then we make sure we make it up to that. Now this first one will be power 1 and this one will be power 2. But since this one is power 1, no need of showing that one, it's a bit primitive. And since all are linear factors, don't even talk of quadratic because they are repeatedly linear. It is linear like x minus 2, but it is repeated 3 times. You understand? But it is still what? Linear. So, because of having linear down on top, we shall purely have constants, that is A, B, and C. Now, the problem is getting the LCM. It is the LCM that usually gives people hard time. That's why I had to write something. Yes, that's why I want to write something about it. Because the LCM gives people hard time. So I'll come here and say, here it is the LCM that disturbs people. You people prepared to write the LCM in the chat, yeah? I want to show you that it is hard. X minus 2. People give me the LCM. Remember, we are handling this. We are on the right hand side, yeah? So I need the LCM of that, that, and that. You write the LCM in the chat, I have a look. Hey, we are 30 people. That is good. People, thanks for being enduring. Hey, people are trying. People are trying. I've liked someone who has said that it is the same as this. Then that person remembers the cheat code. The person remembers the cheat code that those two are supposed to be the same. I like that. But those who don't get this, you can use the other format of LCM for the method of primary. You see that the thing will come out very well. It will come out very well and you will not be stressed at all. It will come out very well. Now, this part of dividing, that when you divide the whole of this by this, you get this. Because this one, like why it cancels, I don't know. So I'll have here my A. Then this will be x minus 2 squared plus B. We go. The whole of this, I divide by this. What do I get? I want to see it in the chat. This is what disturbs people the most. Dividing this by this. What do I get in the chat? You write it. We are dividing this by that. What do I get in the chat? Jonathan is saying in the chat, this one is the correct one. Please, you go back and revise your partial fractions well. I don't want you to cram. You go back and revise your partial fractions very well. Our e-library on the website has textbooks of mathematics. Our drive has textbooks. You go there and make research. I don't want you to be rigid about wrong things. So here we have, so it's like we lose one of the x minus 2 here. So this one remains as x minus 2 plus. Then the last one is easy because we are dividing this by this. So we remain with only this. You understand? So we shall have our c into 2x plus 1 like that. Yeah. And things are done. Yeah? So down things are okay. You all know we are supposed to come and rewrite. So I want someone who has really mastered these things to unmute and take us through how we shall get the value of A, how we shall get the value of B, how we shall get the value of C, because I'm not going to do them. It will be unfair. Because literally everything has been talked about in this topic. Gladys Gift. Yes, Gladys Gift.
Okay.
Gift, I want to get the value of A. What should I do?
To get the value of A, you eliminate B and C.
B and C, isn't it?
Yes.
I don't want you to keep quiet. Don't mute. B and C have that in common. What can I set? And they are eliminated. X is what? Which value can I put there? And it puts there a 0 and it eliminates those two. Don't mute. You want to run away?
No.
What should I put? People are saying 0. You people, you are lying. 0 can't work. When you put there 0, 2 times 0 is 0. Plus 1, it is 1. B has not been eliminated. Remember, for you people, I want you to be good mathematicians, but for you don't want to learn. Let me teach you a technique. For you to eliminate this B or this C, the whole of this should be -1, isn't it? So that -1 plus -1 is a 0. So you want the 2x to be -1. Don't you see that I'm supposed to let x as -1/2? Was understood? Someone is saying -2. That is not right. Who has understood with the trick that for you to eliminate B, remember we are playing with 2x. The whole of 2x should be -1, so that when I add it to 1, I get 0 and 0 eliminates everything. So since I want my 2x to be a -1, I equate the 2. So I will have to set my x to be -1/2. I don't know. People are saying 0, 0. Because when I say X, they remember what they have been going through in their relationships. Everything you just want to say 0 as far as your X is concerned. This is not about personal issues. What if I set X to be -3? Remember, you want the value of A. And why do you want -3? For what? We want the value of A, so we want to eliminate B and C. B and C have that 2x plus 1 bracket in common. And the only thing that can be put there and things are eliminated is -1/2. Yeah?
Yes, sir.
So I will have squared plus 29. Those with calculators, get ready. Minus 11 equal to, this is A, -1/2 minus 2 squared. This one is easy. Sorry, this one is very hard. 2 into -1/2 plus 1 -1/2 minus 2 plus C 2 into -1/2 plus 1. What do we have on the left? These things are very hard and very weird. People, what do we have on the left? Let me check. That is a quarter, that is a half. Minus 29 over 2 minus 11. I'm getting -25. Is it true? Then things are easy. -25 looks correct. This is 2 over 1. So I think 5 over 2. Here I have 25 over 4. Is it? 25 over 4A. Then the other side I have zeros. I can even just put the very big 0 because I know everything has been eliminated. And I'm getting my A as -4. Is it true? Do I have anyone else with -4? Let's check and see what these people this side have. Yes, even these people having here -4. So we are okay. You people are delaying me. But you know we have substituted together and the substitution is very correct. This has been just algebra. So you see we now have A. We now have A. Now you people, are you seeing this other common bracket? So I'm going to remove this. I'm going to remove this. I'm seeing this other common bracket and I'm going to make use of it. X minus 2. And when I put here 2 and put here 2, I will eliminate B. I'll eliminate A, I'll eliminate B, and I'll get C. Do you see that, people? There is that common bracket of X minus 2 on A and B. And when I use it to put there a 2, I'll eliminate A and B, then I'll get a C. Isn't it? So let's utilize it. Let's utilize it. So let's set our X to be a 2. I will set 2 into 2 power 2 plus 29 into 2 minus 11 is equal to A into 2 minus 2 plus b square bracket c 2 into 2 plus 1 2 minus 2. I'm using that substitution above, yeah? But wherever I'm seeing negative a half, I am putting 2 because we first substituted for 2, yeah? Sorry, for negative a half. So this one is c into 2. You people, we had a bracket here. This bracket was supposed to be here. Like this, then plus 1. This one is 2 into 2 plus 1, like that. Hope we are together there. This one is 8. This one is 58. Then I have 66. Then I have 55. Hope you have 55 here. I've been using my bald head. Yes, 55. Why is it that on me right I got negative 5 over 2? You check your calculator well. Substitute well. So I know this one is a into 0. So here, let us write well and substitute well. Those people may wiseacre. And here you say, this one is b. You can even decide to be a very good math student and say this one is b into, I'm seeing here 5, then a 0 later. Then you come here and say this one is 5c. So c, I'm getting 11. Even 11 looks correct. I'm not sure, but it looks correct. Wrong values are easily seen. You get weird things. Very weird. Hey. Now, people, we are done. We used negative a half, we used 2, and we got our 2 values of a and 4. Now it is time to struggle for this b. It is time to struggle for this b. Now, since b has no formula, because b has both, yeah, you can now decide to use what is easy for you. You can be like, let me put there 0. You can be like, let me put there 0, because when you put there 0, you are cancelling this, you are cancelling this, you are cancelling this, you're cancelling this. Even these ones are just like dead space. So that 0, always think about it, yeah? Makes work easy in the end. So let us set our x to be a 0. So we recently substituted for 2. So wherever there is 2, we are going to be putting 0. So 0 squared plus 29 into 0 minus 11. Or someone can decide to use 1. Maybe that's what they want. So value of a, we got it as 4. Was it a negative? Yes. So a is negative 4 into 0 minus 2 plus b, which we are looking for. Here we have 2 to 0 plus 1. On this side we have 0 minus 2. Then plus c, we got the value of c as 11. We have 2 into 0 plus 1, something like that. Yeah. Now, what do we have here? Here we have negative 11 equals, here we are having positive 8. Then here we are having, this is 1, that is negative 2, we have minus 2b. Then lastly we have 11. So when 11 goes the other side, it will be negative 22. Goes the other side, I'm getting my b as 15. So my C is 11, my B is 15. Let's check and see if we have similar values. Hey, you people, here C is 11, which we have, but there B is 3. What is wrong? Finally, my empty head disappoints me. What is wrong? Oh, this one is... Where is the problem? Where is the problem? Where is the problem? Hey, people, where is the problem? So you made it is 16, not 8. Oh, this was squared. Yeah, that was squared. By the way, you people, even this one was squared, though it was a 0. You see, that is the only person following. But here I think we squared, yeah? Yeah, so this is 16. Thank you very much. And the 16 is a negative, you understand? Yeah, this is negative 16. Thank you for following. Thank you for that. And you people here, eh? Negative 2 squared is 4. 4 times negative 4 is negative 16. So this one, it finally comes out, eh? Because this will be 5 minus 11, negative 6. So we get a 3. Yeah, thank you for that. At least I have someone following. So A is negative 4, B is 3, C is 11. And you people know how to conclude. Maybe I can help you conclude for the last time. For the last time. So the question was 2x squared plus 29x minus 11. The first thing here was 2x plus 1. Then here we had x minus 2 squared. So the A was a negative 4, as you can see. And this was it. The next was a B, which was a 3. And it was the repeated one to power 1. You can put it in brackets. Then the last one was a C, which was 11. And it was the repeated one to a power 2. You get? I've just been getting that from our last working. And with practice, you also be in position to do that without necessarily going back to the question. So I want people to look at that working. Hey, but you people, today we have covered a lot of work. Truth be told, I didn't know that we could complete partial fractions in around 4 hours. And yeah, 4 hours have actually helped us. We are done. So you people, is that okay? And that's what these people have. Negative 4, 3, 11. See? Negative 4, 3, 11. But for them, they were doing things of comparing coefficients, which are very hard. Ours are easy. You go with those. And you can see the next thing is exercise. And that is assignment 4. Hey. So you people, is that okay? Is that okay? At least we have ended with more than 20 people. That is nice. You people, you are more than 20. I want 10 people to tell me it is okay. Thank you, doctor. It is okay, thank you, doctor. It is okay, thank you, doctor. It is okay, thank you, doctor. It's okay, thank you, doctor. It's okay, thank you, doctor. As people take screenshots. I want to see those many messages. It's okay, thank you, doctor. 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 It's okay. Exercise. You take a screenshot for this assignment 4. The answers are also there in brackets for some, of course. You take that screenshot for the assignment. I really love this book. It saves me from writing assignments. I think I need the same solution in chemistry. But chemistry notes, I don't know. Shall find a way. So that is it, for assignment 4. Research work. Improper fractions. So let me sign out. So the research work. So the research work is the last part D. You can make research about improper fractions, how they are dealt with. After all, I talked about them, how they look like, you know everything. If you have been taking note from the beginning. And I don't want you to be worried, just because they have the concept of long division. Do you see this? The word is even here. We use long division. So you just need long division. And you see, they are the same things we have been doing. Can't you do this? Just one example, even to this one. Can't you do long division there? That one is your own research, And then the exercise for long division is there, and this one is the final. But you don't need the final if you have the other ones. The final will now come later. After all, you have the other ones, But a good student is taking screenshots so that later they can follow up. But you're going to receive the book, The uses are there. So this chapter is done, as you saw. After this one, next chapter, trigonometry. Chapter 5. You have assignments, you have research work. So when we go to your syllabus book, these are now weird things. Linear, covered. You know what proper means? Quadratic, covered. Repeated, covered. This one is your research. So, as I promised, I'll always endeavor to do for you 80% or 90%. Then I'll always give you research as either 10% or 20%. So the topic is done. There is a lesson I'm scheduling soon. The lesson will go for 10 hours. 10 hours. If you die, you die. Even if I reign with one student, I'll keep pushing. And I'll put the video on the drive 10 hours straight. So I'll sign out. But you people, all you have to know, this holiday, we are not going to study a lot. Why? The work that you need is already covered. Yes, those who want to get more of our services, I told you go to our website and create an account. chemmathonline.com. And then, yes, Jonathan, as if you have something to say. Then this is my number for strictly WhatsApp calls.
Yes, Doctor, thank you so much for today's lessons. It has been really so motivating and so interesting. But I just wanted to remind you, you promised to tell us today what Janet Museveni said.
I've not yet told you.
Not yet.
That means you dodged the morning lesson. You
Doctor,
dodged the morning lesson.
I wasn't aware.
Hey, I'll give you the recording. No, you did the morning lesson. I taught friction in the morning. I said whatever Janet himself said. I taught friction in the morning. It was from 11 to it was from 10 to 10 to 11, 10 to 1. 10 a.m. to 1 p.m. You look for that recording unless you people have not posted the recording. Unless I forgot, because you people annoy me always. But I taught in the morning and I think I posted everything. Unless you say that I've not posted anything in relation to friction.
Okay, doctor.
Yes, but I'm going to I'll brief you. After this session, you call me, I tell you. But anyway, it
doctor.
was just a proposal. Don't be worried. Before you read and get the content, you people are going to be blessed because your year is trial and error. Even the papers you did at O level, trial and error. So if that's how you're going to move, like that. You just pass papers, then you finally come and join us at medical school. Join us in the outside world. You come and we let me leave that. Okay, I wanted to show you something small about this drive. Why I'm saying that we are not going to study a lot this holiday. People are not aware about what I exactly mean by that. The fact is that we are not going to do a lot of things this holiday. Let me show you something small here before you sleep, because personally I'm worried. So you people, if we are supposed to complete senior 5 work, for example, today we have been doing math. So when I come to math work, yeah, and I come and senior 5 maybe term 2 work. Term 2 work, we actually covered this work last holiday. I've seen all these topics. The only thing we have not tampered with is permutations and combinations, which we may not tamper until next holiday. This is term 2 work. Dynamics, 1 lesson. Probability, 1 lesson. Differentiation, 1 lesson. Integration, 2 to 3 lessons. You understand? If I count the lessons that we just need, okay, in simple terms, this holiday you need to concentrate more on what we already have. Because for this term 1 work, descriptive statistics, those ones, people know, I don't know why. Trigonometry is what is bothering me. But when I come here under equations and inequalities, polynomials, those ones I taught, and they are the hardest. Partial fractions, they are there, I'm done. I'm going to put the video there. But then when I come to term 3 work, let me see. Term 3 work has random variables, discrete and continuous. Discrete, I completed. Continuous, the lessons are there are 5, and none of you has watched them. They are there waiting for you. Very long videos. When I come to probability distribution, you have binomial, the lesson is there. You have normal, the lessons are there. 3 of them. And you're supposed to watch them before you go back to school. Because these are the topics that are going to dominate next term. So you need them. The only thing that we didn't cover is uniform. And you saw that uniform has 2 pages, 30 minutes. So that means the only things we haven't covered in the work of next term, they are only and only 2 topics. Those are series and error analysis. I'm beginning because this is a topic of pure math, partial fractions. That means on Wednesday I'm supposed to begin a topic of applied, which is error analysis. So on Wednesday we are beginning errors, and I'll complete errors in 2 classes or 3. But mastering this probability. Remember for chemistry, For chemistry, you always want to analyze these things with you. So you realize for math, we just need one serious week to complete whatever you need to go with. For chemistry, term 1 work, we completed moles and equations and these things of electronic structure. I don't want to go back. Bonding and structure, we keep meeting it in different topics. That one may not stress me, but I may revise it. I just need one night. When I come to term 2 work of chemistry, we have organic chemistry part 1. We completed alkenes, we completed alkenes, we completed introduction. We just need alkynes. And alkynes, I promise you, it's going to be one lesson. And I may teach it tomorrow. One lesson like this. One, and I'll be done with all the organic chemistry, part 1. Then, term 2, we are really badly off. For chemistry, we have thermal and periodicity. So those are the burdens of chemistry, because we are supposed to explain those things from scratch. But what if I give them next week? And I say that next week we are only doing thermochemistry and periodicity 1. Then I say this week we are going to do all that math and alkynes. Because senior 5 for chemistry term 3, I think we are sorted. Because it has organic chemistry part 1, benzene and methylbenzene halogen compounds. Those ones I'm going to do them on weekend, because I need a weekend to, I need both days of the weekend are enough for me to complete this part. For this part of equilibria 1, there is this topic called the chemical equilibria. It has 8 lessons there already. When are you going to watch these 8 lessons? When? I'm wondering. When are you going to watch those 8 lessons? None of you has watched. And this is a topic that we'll begin with next term, trust me. And in the last week, I want us to start ionic equilibria. Maybe I'll do solubita equilibria next holiday. I don't know if time will allow. So literally, trust me, this time round, you people will go with a somehow good coverage. Because today is a Monday, it's like the first day of the holiday. But discrete probability is done. Alkenes are done. Polynomials are done. Partial fractions are done. You understand? In just 1 week, 4 topics. If we just maintain that pace, maybe this week we cover 4 or more, or 5 or 3. Trust me, in the last week of the holiday, I may not teach. I may just leave you to concentrate and make notes. Trust me, if you don't make notes for the work we teach, even at school, these things will keep disturbing you. Yes. So make sure in whatever you're doing between now and end of today. Today is Tuesday. Make sure you get money for the drive. Math is just 25k, all senior 5 topics. Chemistry 25k, all senior 5 topics. You enjoy for the holiday until term 3. I only turn it off when term 3 is done, because there I will have uploaded more work and it will be paid for. So let me hear from Kalanzi and I say bye-bye. Otherwise, thank you for attending. Unless if someone has a concern, but that is my advice. I'm really not scared of this holiday. The work is there. I'll do the needful. Even if I maybe leave out one topic, you can struggle with that one on you also struggle core. Hey. Yes, Kalanzi.
Good morning, sir.
Yes, please.
Thank you for the service. We really appreciate for that. But my inquiry is, when did you send the what? The link for the morning lesson? Because I was in the group, I never saw anything.
Then I'm going to check and send. Maybe it skipped my mind. I handle a lot of things.
Even the recording, none of it is there. Because you have said that you had a lesson at 11, but since 11 I've been on sending some people's things, what and what, then communicating, but I never saw anything from the
Okay,
groups.
I'm going to handle that.
Okay, thank you,
Okay,
sir.
don't go off. You pray for us in Islam and give us the closing prayer, or in any language. Then we go.
Okay. I pray in Islam.
It's okay.
أشهد أن لا إله إلا الله أستغفرك ربنا آتنا في الدنيا حسنة وآخرة حسنة وقنا عذاب النار أشهد أن لا إله إلا أنت وأستغفرك وأتوب إليك اللهم آمين.
I mean, but I've not heard somewhere $1 million. What is $1 million in Arabic?
I don't have $1 million.
Okay, mashallah.
بإذن الله.